Hello everybody, welcome to the channel, and I am very excited to present one of the most comprehensive Kubernetes crash courses on YouTube. We're going to cover a ton of Kubernetes concepts. I'm going to explain them in great detail throughout the crash course with a lot of diagrams, and we're also going to practically use Kubernetes by deploying an application locally on our Kubernetes cluster. So, in terms of prerequisites, I do expect you to know a little bit of Docker. So if you know absolutely no Docker, I highly suggest pause this video, read some Docker documentation, or watch my Docker crash course on YouTube. I have one on my channel as well. So with that being said, let's actually go through what we are going to be learning in this crash course. So the first thing we're going to do is we're going to introduce Kubernetes, and we're going to explain what is Kubernetes and why would we ever want to use it. Over here I abbreviated Kubernetes with K8S, and that's basically just an abbreviation of Kubernetes. So K is the first name, S is the last name, 8 is all the letters in between. And we're going to see that throughout the crash course. So this basically stands for Kubernetes. The next thing we're going to do is we're going to explore the Kubernetes cluster and the components within it. So that is the next thing we're going to explore. And then we're going to install Kubernetes on our local machine. So we're going to figure out how we do that. After we do that, then we're going to explore Kubectl, which is the Kubernetes CLI. Next thing, we're going to explore our very first resource type known as pods. And then we're going to start talking about services, which is another resource type in Kubernetes. And then we're going to start talking about networking and how we can have pods communicating with one another in our Kubernetes cluster. Then we're going to talk about another resource type known as deployments. And then we're going to talk about a very specific service known as Ingress. And then we're going to talk about persistent volumes and persistent volume claims. And then we're going to talk about storage classes. And then we're going to talk about another resource type known as secrets. And the last two things we're going to talk about are requests and limits. So I'm going to cover everything here in such great detail. And if you want to watch one over the other, I have timestamps in the description below. So you could watch, if you want to learn about Ingress and you don't really care for learning about services and pods, then you can go ahead and skip to that timestamp. However, we're building on top of everything that we have learned. So really, I highly suggest watching the whole video. But if you want to basically learn about storage classes or persistent volumes, I try to make those sections as comprehensive as possible and not really dependent on other things. So you could very well do that. Now that is what we will be covering in this Kubernetes crash course, and I like to, well, teach you guys by doing something. So we're going to deploy a very simple application on our local machine, not on a cloud provider. So we're just going to deploy it on our own Kubernetes cluster. And if you don't know what Kubernetes cluster is, completely fine. But this application is very simple. We have a client which is going to be built with React and TypeScript, and this is going to be a server right over here. And then we're going to also deploy a MongoDB database. And this is going to be inside of our Kubernetes cluster. And when I deploy it to our Kubernetes cluster, because the environment is going to be very similar, the same configuration is going to apply for AWS or any cloud provider. So you do not have to worry about that. Alright, so this is the application that we are going to ultimately be deploying with Kubernetes, and it's ultimately going to look something like this. So it's just a very simple application. We can basically check, the habits. Have we done them today, or we haven't done them today? Literally these side navs, they do nothing. I just put them there just for design. And then essentially now what we can basically do is we can add a habit in if we want to. So let's add another habit. Let's say, I don't know, make YouTube video. So this is another habit, and we can add it in there, and we can also check this off. Now if I refresh this, well, it is going to persist because we are saving it to our MongoDB database. Now, I have created the images for the client as well as the server. So you don't have to worry about no coding. You don't have to worry. You can be a complete coder. You don't have to have any coding knowledge. I already created all of the images and I published them publicly on Docker Hub. So the two images that we are going to be using is latharb/server and latharb/web app. This is going to be, well, the React TypeScript application, and then this is going to be, well, the server. This one you can neglect. I'm going to delete this a little bit later. But these are the two images, and then we're also going to use, of course, the MongoDB image that is hosted on Docker Hub. Now, if you ever get stuck or you want a point of reference, please go to my GitHub page at harblathe7/k8app. At the moment, it is private, but I will make it public once I publish this video. And over here, we can see basically the client code if you do want to take a look at it, as well as the server code. But really what you're going to be working with is the infrastructure directory over here. So click on infrastructure, then click on K8, and then you're going to see all of the manifest files that are going to exist inside of this crash course. So all of the manifest files. So you can basically look at these manifest files for reference if you want to. Now I also branched everything out. So, you can basically go back to previous versions. So if you want to go back to maybe the first time where we created our first manifest file, you can go over here. So you're not overwhelmed by all the final product. So you can basically kind of step by step it by going to different branches. So I hope that kind of gets you excited with Kubernetes. This crash course really took me a long time to make, and I hope it becomes really valuable for you guys to learn K8's Kubernetes. I'll see you in the next section. Now let's start talking about what Kubernetes is and what kind of problems it ends up solving. Why would we ever want to use Kubernetes? Now, Kubernetes is a container orchestration tool that manages scaling, deployment, and recovery of our containerized application. Now, that might not make a lot of sense, so I have a few diagrams that will hopefully kind of clear up what Kubernetes is ultimately trying to do. So let's say here that we have an application, and this application is consistent of 3 running containers. And these 3 containers are inside of some sort of server, some sort of virtual machine. You can think of this yellow box as maybe an EC2 instance that we can find on Amazon Cloud Services. So these containers are running in this virtual machine and everything is fine and dandy. These are the containers that are needed to run our application. Now everything is fine, but what if sometime in the future, one of the containers goes down? So let's say that this container 2, it goes down. And at this point, we only have container 1 and container 3 running, but we don't have container 2. And let's say we need all 3 containers to be running for our application to run properly. Well, in this case, if you're not using any sort of orchestration tool, you're just deploying maybe Docker containers into this instance, well, at that point, what you would have to do is you would have to manually check the container, see that it has crashed, and then restart or spin up a new container. You would go ahead and have to do that manually. Now the problem with that is there's going to be downtime from when the container has crashed to when the container has spinned back up. There's going to be a significant amount of downtime. Now you can say, okay, no problem, I only have 3 containers in this application, so I can just consistently check this and just spin up any container if anything goes and fails. Well, what if a container failed at like 3 a.m. in the morning? So if it failed at 3 a.m. in the morning and you woke up at 7 a.m. in the morning and you went ahead and checked your containers and you realized that this has failed, well, that is a significant amount of downtime. And that is something that you do not want to have in your application. Now, this is a relatively simple application. This is a very simple application. So most applications look a little something like this. They have multiple containers that reside in multiple servers, multiple virtual machines. And to actually go ahead and manually check every single container, check the health of every single container, and check if one has crashed and then manually updating it is pretty much impossible with large-scale applications. Now, this application itself has 33 containers and it is already big, and you can already see how hard it can get. Now, typical applications for large companies have much more running containers than this across many more virtual machines. And for instance, Google has billions of containers running, and even smaller companies can have thousands, if not millions, of containers running. And to manually do these checks is pretty much impossible. So how do we fix this? Well, this is where Kubernetes comes in. Kubernetes to the rescue. So what Kubernetes does is it automatically checks the health of every single container. And if a container fails, so let's say container 15 crashes or it fails, what it does is it checks the health of this container and it's going to automatically either restart it or replace it or spin up another container. So what it does is it ensures that our containers will continuously run, and it will automatically restart them if they fail. And that right there is essentially what we mean by an orchestration tool. It does a bunch of different things. Now, this is just one example. Let's look at another example of where Kubernetes can help us. Let's go back to this over here. We have three containers in our application. And let's say that we have a lot of traffic going into container 2. And so because we have a lot of traffic, we might end up with a bottleneck if we're only running one container. So in that case, what we would have to do is we would have to realize, hey, container 2 is getting a lot of traffic, and then we would have to essentially configure multiple instances of container 2, and then we would have to configure a load balancer that is going to balance the load across these containers. Now this is, well, again, it's very tricky to do, and we probably don't want to do this. Now, well, just so happens that Kubernetes can do this for us. So Kubernetes can essentially watch and basically see, okay, how much traffic are we getting? And if we get a lot of traffic into a specific container, Kubernetes will just automatically spin up multiple instances of that container. So at some point, Kubernetes is just going to be like, okay, well, I'm going to horizontally scale this application. And we could just be in bed and we would have literally no idea that Kubernetes did this, but it did do it. And it can basically configure a load balancer and essentially distribute the load accordingly. And this is a lot better than, well, having to manually do it with our own Docker containers. So that is another benefit of Kubernetes. Now, there's so many more benefits of Kubernetes, and I'm not really doing justice of Kubernetes with just this one video, but there's so many more benefits. Another benefit of Kubernetes is that there's easy rollback. So let's say we go ahead and we update our application and we realize that our application has, well, it's failing. There's a bug in our application. With Kubernetes, we can easily roll back to a separate version of our, or previous version of our application. Another benefit is not restricted to any cloud provider. So essentially, we can easily, very easily, if we have deployed our application in AWS, we can very easily move our application to Google Cloud or move our application to Microsoft Azure, because it's not restricted to any cloud provider. All we really have to do is just provide the YAML files, and we'll talk about that a little bit later, to whatever cloud provider that we're using, and there we go. We have just deployed our application. So it's really great in that sense. And also, in terms of development, testing, and production, it is very similar. Each environment is very similar to one another if we are using Kubernetes. Another benefit is it automatically configures your infrastructure. So we don't have to go in there and manually create load balancers and all the kind of complex things. Kubernetes will automatically just do that for us, and it will do that for whatever cloud provider that we use, because all the cloud providers have a lot of Kubernetes support at this point. At least the big three have that. Now, it will also very much speed up deployment, so we can very easily deploy things with Kubernetes. We can set up continuous integration. Again, because the environment is so similar, we can set up a good testing environment, staging environment. We can do that all with Kubernetes very easily. And last thing is, well, it allows us to build more complicated applications. Now, as our application grows, we're going to have multiple containers, and the only real way to manage all those containers is with an orchestration tool like Kubernetes. And Kubernetes allows us to do that. Now, with the popularity of microservices, microservices are very typically deployed with a Kubernetes infrastructure. And that's because we have multiple services and we have to manage each one of these services. And we typically do that with Kubernetes. So these are just some of the benefits, and there's so many more benefits of Kubernetes. And we're actually going to see them throughout this crash course, but I might also miss some because Kubernetes does just so much. So I hope that gets you excited, and I'll see you guys in the next section. Now that we have a good understanding of what Kubernetes is and what problems it's trying to solve, let's dive deep into the Kubernetes components. And to truly understand Kubernetes, you have to understand what a Kubernetes cluster is. And a Kubernetes cluster is essentially a cluster of all of the components, all of the resources needed to run your Kubernetes application. So let's start looking at each component in great detail. So the first component that we are going to talk about that is comprised in the Kubernetes cluster is the worker nodes. And we can have multiple worker nodes in a Kubernetes cluster, but we need to have at bare minimum at least one worker node. Now, worker nodes, you can basically think of them as computers, as machines that essentially are going to be used to run our containers. So we have a worker node, and it is going to be used to run the container in our application. Now in Kubernetes, there is nothing known as a running container on its own. Containers are always wrapped around with pods. And that is basically what you see over here. So you never run a container in isolation. It is always wrapped around with this thing known as a pod. And a pod is the smallest unit in Kubernetes. Now, a container and a pod are typically a 1-to-1 ratio, but it is very possible to have multiple containers that work very similarly and work well together in the same pod. So we can have multiple containers in the same pod. But in practice, it is almost always a 1-to-1 relationship, and in this crash course, it will be just a 1-to-1 relationship. Alright, so far we have our nodes, and we can have multiple nodes, and within these nodes we have containers running inside of these pods. Now within the nodes themselves, there's also a bunch of software and tools that are needed to run our Kubernetes cluster. For one, we would need to have something like Docker. So if we are running Docker containers, our worker node, our virtual machine, would need to have an instance of Docker installed in order to run these containers. Now, another thing that it has is the kubelet. And the kubelet does a bunch of different things. But the main two things that it does is it manages the containers inside of the application. So it manages the pods inside of this node worker. And another thing that it does is that it communicates with the master node. So it's in consistent communication with the master node. And we'll talk about the master node in a few seconds, so don't worry all too much about it. Also, there's something known as the kube proxy, and the kube proxy is essentially, it maintains the network rules on the node, and it allows for network communication. So it allows for network communication outside and inside of the node. Alright, so I hope that kind of clears that up. Now let's start talking about the next component, the master node. So the master node contains a bunch of different things. So we could have one or many master nodes as well. In this example, we only have one master node, and the master node is pretty much responsible for maintaining all of the worker nodes and the pods that are running within them. So that is basically the responsibility of the master node. Now, the master node contains the API server, and this is basically going to be used to communicate with the kubelet. So it's going to be used to communicate with the kubelet, and we can also we can also communicate to the master node through the API server. So we can have either UI interface to communicate with them, or we can communicate with the API server with something known as Kubectl, which is the CLI for Kubernetes. And this will allow us to communicate to the master node, and then the master node will communicate to the worker nodes accordingly. So this is just the main way of communication. Another thing that we have are schedulers, and schedulers are basically used to, well, schedule in certain pods in certain nodes. For instance, let's just get rid of this pod over here. And let's say that, we told our master node that we want another pod inside of, well, one of these worker nodes. We want to run another pod. Now what the scheduler does is it basically looks at all of the resources inside of this worker node, all of the available resources inside of this worker node, and it looks at all of the available resources inside of this worker node, and it looks at the resources needed to run this pod, and what it does is it basically decides where to place this pod. Now if this, let's say if this doesn't have enough resources, then it decides to place this pod right over here in this worker node. So basically it is a way to essentially place pods into their correct location. And another thing that the scheduler is responsible for is eviction. So let's say that this pod is now using so much resources that it has essentially is taking up more resources than is available inside of this worker node. Then it is responsible for the algorithm for evicting pods. So it would go ahead and evict pods. All right, so that is the schedule over here. And then the control manager basically is very important for detecting changes inside of the Kubernetes cluster. So for instance, if this ends up failing, and crashes, the controller would go ahead and see this change, and then it would communicate with the scheduler saying, hey, we need to spin up another instance of this pod. And that is basically what it's doing. And so it just basically tries to maintain the state of our Kubernetes cluster. Now, altogether, all of these things, so the master node, the worker node, the pods within it, are going to make up the Kubernetes cluster. So this right here is the Kubernetes cluster. And how do we create this Kubernetes cluster? Well, we create this Kubernetes cluster by defining all of the resources and components that are within our Kubernetes cluster. And here are just some of the components that we are going to be defined. Now, there's a lot of different words for all of these things. Some people call them resources, some people call them components, some people call them objects. So be careful, I might use either one interchangeably. I typically just call them resources. But we basically define all the resources that are needed inside of our Kubernetes cluster in these files known as YAML files. And then we essentially give them to whatever cloud provider or whatever local environment that we are running our Kubernetes cluster on, and it would then create this Kubernetes cluster. So in some cases we have to create the worker nodes, and then it will create all the resources and start using all the worker nodes and the master nodes that we have created. Or we can basically use other CLI tools that create these master and worker nodes for us. But essentially all we're really doing is we're defining these things. And I only show you these things over here. We're going to be defining more throughout the crash course, and there are so much more that I won't even cover, but these are kind of the main resources that we are going to be defining. So we have seen pods already. We haven't seen services, we haven't seen Ingress, we haven't seen the other ones, but do not worry, we will cover each one and I will explain each one in great detail, along with some other ones that you don't see right now. So I hope that kind of clears it up, and I hope that makes sense, and I hope it gets you excited for the next few sections. Now, enough of the theory, it's time to actually start using Kubernetes. Now, to do that, we first have to install Kubernetes on our local machine. However, that kind of provides a little bit of a problem. And the reason for this is because Kubernetes usually runs across multiple machines. So over here we have multiple worker nodes, and we can potentially have multiple master nodes. And in your local environment, this is pretty much impossible impossible to configure. So to get around this, what we do instead is we run our Kubernetes cluster on just one node. And within that node, we have our master and our workers. And this is known as a single node cluster. And this is possible to do in our local machine. And this will allow us to actually run a Kubernetes cluster and start working with it and learning it locally on our machine. So that right there is the single node cluster. Now to communicate with our single node cluster, we're going to use the Kubernetes CLI, which is Kubectl, and essentially this is going to communicate to the API server inside of the master. Now this is not just used for local development, this is also used for production. So this will also communicate with the master node inside of a large Kubernetes cluster as well. So this is exactly the same. So we're not really missing out on by using a single Kubernetes node cluster. So that is fine. Now, how do we get this single node cluster? Well, to do that, we have two options. We can either go this route or this route. So the first route is Docker Desktop. So essentially we would just install Docker Desktop and we would enable Kubernetes to create this single node cluster, or we can use something like Minikube to do that. Now in this crash course, we will be using Docker Desktop to enable Kubernetes. And the reason for this is because it's so easy to do. So that is what I am going to show you. However, if you want to go with the Minikube route, I will provide some links in the description below, and there isn't going to be much changes across these two. So you can still follow along accordingly. You can really use either or. However, I highly encourage you, if you can, to use Docker Desktop, because that is what I will be using in the crash course. To install Docker Desktop, just go to docker.com-products-docker desktop. And over here, you can see that this is the official homepage of Docker Desktop. Now I am on a Mac, so I'm just gonna go ahead and click on Mac with Intel chip. However, if you are on a Windows or Linux machine, just click on one of these and follow the instructions accordingly. Now I'm just going to continue with Mac. So I'm going to quickly just click this button, and this will take a little bit of time. So I'm just going to pause the video and wait until this is done. This is done, so I'm just going to go ahead and click on it. And hopefully this doesn't take a lot of time, but I'm sure it will. So I will again pause the video and just wait until it is over. So now that that is done, I'm just gonna drag and drop this right over here into my desktop. So I'm gonna pause the video and wait until this is over. So once that's done, go ahead and open up Docker Desktop, and you should see a GUI that looks a little something like this. And now we actually have Docker inside of our local machine, and you can see here that Docker is running appropriately. Now if we want to go to Kubernetes, then we would just go to the settings over here, and then we would just very simply go to Kubernetes, and then we would just say enable Kubernetes. And to enable Kubernetes, we have to apply this and restart it. So let's go ahead and do that. And this is going to take a little while. So again, I'm going to pause the video and I'll be back once it's done. Okay, there we go. So we should now have our Kubernetes single node cluster on our local machine. Now to double check that everything works, we could open up our terminal and then write kubectl. So if I write kubectl, we should see all of this. And kubectl is the way that we are going to communicate with our Kubernetes cluster. It is the Kubernetes CLI. Now, the reason why we got this is because doing this would install kubectl as a dependency, and that's why we got that on our local machine. So if you do kubectl and you get all of these possible commands that you can do, then congratulations, you have Kubernetes inside of your local machine. Let's start interacting with our Kubernetes cluster through the Kubernetes CLI. kubectl. Now, a quick reminder as to what kubectl is. Kubectl is the Kubernetes CLI that will allow us to communicate with the master node and thus ultimately our Kubernetes cluster. And we can tell the master node a bunch of different things. For instance, we can tell the master node to create a resource. So let's say we want the master node to create a pod, we would tell it that, and then the scheduler would just schedule it to one of the worker nodes. If we want to delete a specific pod, we would just tell the master node that, and it would go ahead and delete that pod. So on, if you want to edit a pod or edit any resource for that matter, it doesn't have to be a pod. It could be a deployment, could be a service, and we'll get into all of those a little bit later. We would just do that through the kubectl commands. So again, kubectl is a way that we can interact with the master node and manipulate our cluster accordingly. So let's actually start exploring some of the commands that we can execute with kubectl. Now remember, if you installed Docker Desktop or Minikube, you should be able to just do kubectl and see all of the different commands right over here. Now there is a lot of different commands, so what I like to do instead is I like to use this cheat sheet over here, because these are pretty much the commands that you're going to be using most of the time, and it kind of omits a lot of the extra ones that you'll probably never use. Like, I have no idea what this does, to be quite honest. So most of the commands that you're going to be using are going to revolve around kubectl get, which allows you to see resources, kubectl edit, even though you're probably not really going to be using this one, and I'll tell you guys why in a little bit. Kubectl delete is a very common one. Kubectl create, you're not going to be using this one all too much, and again, I'll tell you why in a bit. Kubectl rollout and kubectl describe is something that you guys will be using quite frequently. And what we would do is we would say kubectl get and then the specific resource that we want to get, or the specific resource that we want to edit. So in this case, there's a resource or object known as a daemon set, and here we're trying to get that. Similarly, we can do the same thing with pods. So we can do kubectl get pod, kubectl delete pod, and similarly with services, as well as secrets, as well as replica sets. So as long as you know your resources and you understand what these commands are, which are very intuitive, kubectl get, kubectl describe, and kubectl delete, create, and get, you should be fine, and you should know most of the kubectl commands. And I know I said that you guys won't be using create or edit all too much, which seems, well, kind of crazy, because how am I going to put resources into the Kubernetes cluster? And I'll tell you guys a little bit about that later, so don't worry all too much. All right, so let me just quickly clear this, and let me just do a kubectl, and I'm gonna do get all. All right, and this is going to get us all of the resources in our Kubernetes cluster. Now, beware that I have deployed a Kubernetes cluster on my local machine. So I'm going to get a different output than you. The reason why I did this is because I want to show you how it would look like. So I'm going to do get all, and you can see here that we get a bunch of different resources. So over here I have my pods, so I have 2 pods, and I can see that, okay, they're running. They haven't restarted, so I get a bunch of additional information. I also have a bunch of services. The only thing that might appear on your screen is this over here, the default Kubernetes service, and over here we can see here the type, the cluster IP, and all things of that nature. Again, don't worry about this all too much. We have another resource that I have called deployments, and I also have resources called replica sets. So that is what happens when I get them all, and this is pretty useful, and we're going to be doing the get command quite a bit. Now let's do kubectl get, and let's do get pods. So let's just do get pods. Well, to do that, you can see here that you only get the pods. If you don't want all this extra stuff, you can only get the pods. Similarly, if you want to get all the deployments, you would just do kubectl, well, get deployments, of course. You would just say get deployments, and you can see here that, well, you get all the deployments. Now let's say you want to learn more information about a particular resource. Let's say I want to learn more information about this pod. Well, how would we do that? Well, we would use kubectl describe and then we would describe that particular pod. And you can see here that you get a lot of information about the pod. So you can see here we have the pod IP, we have the image that is associated with the pod, we have the image ID. What else? What other information do we have here? We have, this over here, which is pretty important, and we'll talk about that a little bit later. But yeah, you can get a lot of information, and you can describe the pod accordingly if you want. Now, if you really want to debug it, what you could possibly do is do kubectl logs and then that pod. So and this is basically going to output the log as if you would just do it in local development. And you can see here that this is just a typical React with TypeScript application. So you can see here TypeScript, and you have the use effect hook is defined but never used. So you can see we have some warnings over here. So this is how we can actually get the internals of our Kubernetes resources. All right. So what about these other things? What about deleting? So deleting is something that we often actually do declaratively, or we do through the kubectl command. So let's do kubectl, and let's just say get all, and let's say I want to delete this pod right over here, or you know what, I'm going to delete this pod. So I'm going to delete this pod, and so I'm going to do kubectl delete, and then so if you want to delete a particular resource, typically what you would say is you would say the resource name. So let's say you want to delete a deployment and then paste it. But I believe for pods, you can basically omit the resource name. So, and it will just automatically default to resources. So over here, you can see, okay, it has deleted this pod. So let's do a quick kubectl get all. And you can see that the pod is still running. And the reason why it's still running is because Kubernetes noticed, the control manager noticed that it was deleted, and then it went ahead and just restarted the pod. So let me just do a quick let's do another delete as well. So let's try to do this again. I was actually expecting the restart number to increase for some reason. I don't know why it's not doing that. So let's do kubectl delete pod, and we're going to delete this pod right over here. Let's get rid of the pod. Okay, and let's do a quick kubectl get pods. All right, there we go. Okay, so I caught that. So right here, you can see that this is terminating, and it actually ended up creating another one. So it didn't actually restart it. It basically deleted this and it ran another one. And that's, again, the power of Kubernetes. So the control manager noticed that this was failing and it was terminated, and the control manager knows that, hey, I need to have at least one pod running that is habit depl, and you can see here that it has basically spun up a new instance. But we'll talk about that a little bit later. That's just another thing that you can do. Now let's say you want to go ahead and you want to create or you want to edit a pod. How would you do that? Well, typically you would probably think you would just do something like, kubectl edit or kubectl create. However, we typically don't create or edit resources in this manner. Let me explain. So there are two different ways of creating and editing resources, and let me just quickly zoom in here. So one way is the imperative way, and this is exactly how we've been doing it thus far. We would basically outline the set of steps that we want our master node to complete. So we would just say, hey, do this step, then this step, then this step, and then this step. So this is something like kubectl create, and then, well, all the resource information. And this is the imperative way of doing it. Now in Kubernetes, we typically not almost never, but very rarely do we do this way of creating resources. We almost always use the declarative way. And essentially the declarative way is basically specifying a file saying, hey, we want our pod to look like this. And kubectl here is the file, and I want you to just figure it out and create a pod or a resource that looks exactly like this. And we would do that through kubectl apply -f whatever file that we want to specify. And this is typically how we create resources. So a quick example, and we're going to be creating these files quite extensively throughout the crash course. So if you don't understand any of this, do not worry, we will cover it. But this is a pod that is going to run an Nginx image. And so what we would do is we would specify all of the things that we want that pod to have, and we would basically give this file a file name. So let's say nginx.yaml. And then we would give it to kubectl. We would say, hey, just apply kubectl or sorry, nginx.yaml. So kubectl apply -f nginx.yaml, and you just figure it out and create that pod, and it will just go ahead and magically do that. And we are always going to use this way for creating most of our resources. And the reason for that is because once we delete everything, we don't want to go ahead and just recreate it our way. Instead, we want to create just one file, and then whenever we delete it, we would just apply our file much easier. And another reason why we'd want to do this is because, well, this is a lot cleaner and it's better documented. So it's a lot less error prone. We can actually see exactly what we want inside of our pod or our resource. So that is another way that we want. That's another reason why we want to do this. So we are almost never going to see the kubectl create and kubectl edit, but all the other commands we are probably going to see. So and that I hopefully explained to you the reason why we want to do this. Now there are certain cases where we would want to use the imperative approach. For instance, what if we want to have some sort of secret? So a secret, you can think of it as an environment variable. And if we don't want to have it inside of a YAML file, we could do it in an imperative approach rather than a declarative approach. But we'll get to probably why we don't even want to do that regardless in a bit once we get to the secret sections. So I hope that makes sense. I hope you got a good understanding of kubectl. Now in the next sections, we're actually going to start coding out our YAML file. So that is pretty exciting. Time for the moment we have all been waiting for. We are going to be creating our resources and putting them into our Kubernetes cluster. Now we are going to start creating our resources with pods. Now remember, pods are the smallest unit in Kubernetes, and essentially they are going to contain the containers that will ultimately run our application. So that is what we are going to be starting with, and we're going to start with creating the pod to run our React TypeScript application. Now a quick reminder, we are going to be deploying an application that looks something like this. So we're going to have a client, we're going to have a server, and we're going to have a MongoDB in our Kubernetes cluster. Now to run each one of these, we have to run them inside of a container, and thus we have to create a pod for each one of these services. Okay, so beginning with the client, that is what we are going to do right now. Now remember, there are two ways that we can create resources. We can do it imperatively, or we can do it declaratively. We are not doing it imperatively for this. Instead, what we're going to do is we're going to create a manifest file that is going to describe how we ultimately want our pod to look like, and then we're just going to tell kubectl create a pod that looks something like this. So to do that, the first thing that we are going to have to do is open up our text editor, and then in our text editor, that is where we are going to create the file. So I am opening up VS Code. I opened up a directory called k8tut. And essentially now what I'm going to do is I'm going to create a manifest file. Now the manifest file is going to be a YAML file. So hopefully you do know some YAML. If you don't, that is completely fine. I'm sure it's super easy. You'll pick up on it as we go through the many YAML files that we have created, that we will create throughout this crash course. So let's create a manifest file. We're going to call this clientpod.yaml. All right. So let me just quickly zoom in here. Let's zoom in a little bit less. And over here, we're going to create basically the specifications of that client pod. Now, if you remember, we had that Nginx specification that I kind of showed you, and this is going to look very, very similar. Now, I'm going to quickly just go through it. I'm not going to explain what I'm doing, but then after I write it all down, I'm going to explain every single line in great detail. So right now you can just follow along, but don't worry, I'll explain every line in great detail a little bit later. So the first thing that we're going to want to do to create our client pod is specify the API version. Now this is going to be v1. Now one thing I want to tell you is with YAML files, the spacing is super important. It actually interprets the YAML file differently depending on the spacing and the tabulation. So make sure it is exactly like this with the spacing, with the spacing exactly like mine. All right, so the next thing we're gonna do is we're gonna specify the kind. And the kind here is going to be a pod. You can probably imagine what that is. And then we're going to specify the metadata. And this is just gonna be a colon, and then we're going to tabulate. And then right now, because we've tabulated, we're inside of the metadata section. And in here, we're going to specify the name. We're going to call this client pod. And then we're also going to specify the labels. And then over here, we're going to tabulate again, going inside of the labels. And now we're going to say app client. All right, so now we're going to go all the way back over here, going back to the metadata section. And we're going to specify the spec, which stands for specification. Then we're going to tabulate, and then we're going to specify the containers. So this is going to be the containers running inside of our pod. Now this is going to be an array entry. To specify an array entry, just tabulate, and then we would just do this right over here, the dash. And then we want to give our container a specific name. So we would say name client. And then let's tabulate again, image, and then the image is going to be an image that I have already created. So I already created this image for you. It's in Docker Hub and is completely public. So this is the image that we are going to be using, latharb-web app. So we're going to do latharb-web app. And the version that we are going to be using is v1 for now. So we're just going to use the v1 version. So that right there is pretty much it. And we can actually go ahead and apply this file relatively easily now. So let's go ahead and let's just save this. Now what I'm going to do is I'm going to go open up my terminal. And the first thing I'm going to do is I'm just going to do a kubectl get all. And now you can see here that it kind of looks a little similar to yours because I actually deleted all the resources. If you're curious as to how I did that, I just did kubectl delete all -- all, and that deletes all of the resources. All right, so now it looks a little similar to that. So now let's actually apply this file right over here to create this pod. Okay, so let's go ahead and do that. So to do that, what we would do is we would do kubectl and then apply -f and then the name of the file. So this is going to be client pod.yaml. So let's go ahead and let's do this. And you can see here pod created. So now let's just do a kubectl get all really quick. And you can see here that, hey, we have just created a pod. And you can see that it is actually not running yet. And what it's doing right now is just, well, it's creating the container. And this might take a while because it is a React application. And over here we can see the other specifications. Now let's go ahead and let's just do this again just to see it. And this again will take a little bit of time. So let's actually just close this terminal off, or maybe go it like this. And now let's actually just start explaining what I have done here. All right, so you guys have a good idea of what we're doing, and then that will buy us some time, and hopefully at that point our container will start running. All right, so what am I doing here? Well, I'm gonna start off with kind, okay, and then I'll move on to API version. So kind is basically the kind of resource that we want to create. Now remember, there's so many different resources. So if I go back here, there's so many different resources, and this is actually an oversimplification of how many resources we have. We have pods, we have services, we have Ingress, we have deployments. And actually, let's do just a quick little search over here. Actually, you know what? Let's not do that because I have something pulled up over here. And this basically showcases all of the resources that we have. So these are all of the different resources that we actually have in Kubernetes. And there's actually probably some that are missing from here as well. So we have a lot of different resources. Now in this case, we are going to be creating a pod. So this is why we have specified the kind of pod, because we want to create a pod. All right, so that makes sense. Now, if we wanted to create a deployment, we would just do something like kind deployment. If we wanted to create a service, then we would just do kind service. So this is very simple. We're just specifying the resource. All right, so that makes sense. But what does this do? What is the API version? So I like to think of the API version as a folder that contains certain resources that we can use. So for instance, let's actually go back over here. And let's go here. And basically, you can see here, if we specify the v1 version, we only have access to a certain amount of resources. So we have access to pods, we have access to secrets, and we have services, and we have access to secrets, along with some other ones that I'm missing. But we do not have access to deployments because that is in a separate API version. And so again, you can kind of just think of these as folders that contain separate resources. So if we actually needed to create a deployment, we wouldn't do the API version of v1, we would do API version of apps/v1. And then we would change this, of course, to a deployment. All right, so that is basically what the API version is. And I know I keep throwing around deployments and all these other resources. Again, do not worry, we'll talk about them later in great detail. All right, so that is basically the API version. And I just kind of feel that the API version is pretty annoying. So what I typically do is when I want to create a new resource, I either look at an example manifest file for that resource, and then that way I can basically see whatever API version it is, or you can just go to a website like this that specifies the kind as well as the API version. Now, this website personally, I think is a little out of date because deployments are not extension/v1 beta 1. I mean, you can find them there, but typically everyone uses apps/v1. But you get what I mean. You can go either search manifest files, or you can look at certain websites like this, or you can basically search the API version of certain resources. So that is basically that. All right, so what is the next step? Well, over here, we're describing the metadata. And the metadata is basically a kind of a label, a name that we can give to our resource. So over here, we're describing the name. So over here, the name, and we basically arbitrarily just call this client pod. And you know what's great about that is because now you can see here when we do a get, you can see here that it's a pod and it's called client pod. So that is just basically the name. This can literally be whatever it is that we want, but typically we want this to be something meaningful. And then we have labels. So over here we have the labels section. And we can have multiple labels attached to any sort of resource, especially a pod. Now, why do we want to do this? Well, we might end up creating multiple other resources that need to interact with our pod. For instance, we might create services that need to interact with our pod. We might create deployments that need to interact with our pod. And the only way that we can interact with our pod is by giving that pod a label and telling that other resource to interact with the pod with this specific label. And this label can literally be any key value pair that we specify. It could be bananas. It could be bananas and monkey. Like it could be literally whatever it is that we want. And we can, again, assign multiple labels to it. And labels do not have to be unique. They can be consistent throughout multiple pods. But again, they're just kind of an identifier for other resources to use. So we can basically say, I'm going to go ahead and just say app client. That is kind of the typical convention of naming things. But to quickly kind of illustrate this, you can see here that here is our pod and we gave it a label of app client. Now, if we ever create a resource and telling it, hey, interact with the pod with app client, with the label of app client, then it will know exactly which pod to interact with. So that right there is the label. So let's go back over here. So the last thing we have to talk about is, well, the spec section. And the spec is basically the specification of the pod. And we're going to see this throughout all the resources because we're going to have to define the specification of each resource. Now in here, in the specification, we're defining the containers that are going to live inside of our pod. And over here, we have an array entry. So we can actually have multiple containers. Remember, a pod can have multiple running containers. So maybe we can have, I don't know, another container like the server for some reason running in the same pod. This is completely valid. However, pods and containers usually come in a 1-to-1 ratio. So that's why we only see one in this case. Now again, over here, we're specifying the containers, and then we're just going to give the container a name. This can be anything. This doesn't really matter. This is for logging purposes. And then we're going to give the container an image. And this is, of course, very important. This is going to be the image that is going to be to create the container inside of our pod. Now, this is just going to be the one that I created, lathe-harb-webapp, and then the V1 version. So I hope that makes sense. I hope that was long enough time for us to just do a kubectl get all. And now, cool. So now we can see that our application is up and running. All right, that is absolutely terrific. So if you know React, typically if you run it in development, what you can do now is just go to localhost 3000. So I'm just gonna go to localhost 3000 and your application should run. However, it's not running. Okay, why is that? Why isn't it running? It says running right over here. It says that it's ready. So why is it, well, not running? Well, I mean, there's a very, very, very good reason for this. And let me just quickly go back to the diagram and let's go back to our cluster. Our pod is running in our Kubernetes cluster that is completely isolated from our local machine. So it is running, and it is running in our Kubernetes cluster, but not our local machine. So we can't do a localhost 3000 to access our Kubernetes cluster. However, what we can do is we can do something like kubectl logs, and then we can basically log our container just to see what it looks like. And you can see that this is a typical React application. So you can see here, React start script, logs, and everything of that nature. So this seems to be working completely fine, and it is running. It is truly running inside of our Kubernetes cluster. However, we don't have any access to it using our local machine. So we need to find a way to access our Kubernetes cluster and access that specific pod inside of our Kubernetes cluster. And how do we do that? Well, we do that with a different resource type known as services. So we have created our pod, but you can see that we don't have access to it inside of our local environment. Now, in order to get access to it, we're going to have to create another Kubernetes resource known as a service. To just quickly explain what a service is basically a way that we can interact with a pod inside of our Kubernetes application. So this is just a quick example that we have here. We have our browser, and our browser is going to make a request to our Kubernetes cluster. So you can think of this as a worker node that contains the pod that we ultimately want to see, which is the React application. So the browser is going to make a request to the kube proxy. The kube proxy is going to forward that request to a service. And then the service is going to know exactly what pod it has to forward this request to. So then it forwards it to the pod over here. And then what it does is it sends back that pod at a specific port. And that way we'll be able to access it inside of our local machine. Now in Kubernetes, there are 4 different types of services that we can specify: a NodePort, a ClusterIP, a load balancer, and an Ingress service. We're going to talk about ClusterIP and Ingress a little bit later, but for now, we are going to be dealing with NodePorts. NodePorts are essentially the way that we can actually interact with our pods in our development environment. If we wanted to interact with our pods in a production environment, we don't use NodePorts. However, we use something known as LoadBalancers. However, for development, we will use NodePorts. So let's actually go ahead and create our service. So to do this, we're going to create a new manifest file, and I'm going to call this client SRV, standing for client service. And again, this is going to be the service that is going to expose the client pod. So the first thing that we have to define is the API version. Now for the kind of service, the API version is v1, which is similar to the one for pods. So the kind that we're going to specify is, well, service, and then we're going to specify the metadata. And so the metadata is basically just a description of that service resource that we are creating. So over here, we're just going to create a name of, well, client service. And we don't have to put any labels in here. Then we're going to specify the specification. So let's go ahead and tabulate. And over here, we're going to have a bunch of different things. So again, I'm going to kind of just go through it, and then I'll explain it in detail a little bit later. So the first thing is we're going to have to define one of the types that we're going to be using. Are we going to be using a NodePort, a ClusterIP, a load balancer, or Ingress? What are we using? Over here, we're going to say that we're going to be using a NodePort. So we're going to be using a NodePort. And then we're going to specify selector. So this is selector, and I'll talk about that later. Do not worry. And this is going to be app client. Now, as you can imagine, this is very similar or exactly the same as the label that we've specified here. So you can probably imagine what this is doing. Okay, so the next step is to specify the ports. And this will be confusing. I can pretty much guarantee you that. This is going to be an array entry because we can specify multiple ports. We're going to say port 3000, target port of 3000. And then the last thing is going to be a node port. We're going to do this 30,007. So 30,007. All right, so that right there is the file for our service resource. So what is going on here? Well, the first line makes a lot of sense. This is just the API version. So just a quick reminder, again, think of the API version as a folder that's going to contain all of the resources that we want. So for v1, we have pod, service, and secrets, among others. So we would just use v1. Over here, we're specifying the kind, which is service. Over here, we're just specifying the metadata. We're calling our service client service so that when we do a kubectl get all, that is the name of it. This doesn't matter. Again, we can call it whatever it is that we want, but it's fine. And if we don't specify this, we don't have to specify this. It will just going to give us a random name, and we probably don't want that. Now in here, we're going to write the specification of the service. So the first thing that we're going to be doing, is specifying the type. And remember, we have 4 different types. So we're going to be specifying the type of the service. So over here, we're going to be using NodePort. And then this is where kind of the magic happens. This is where we're going to see how important the labels are. So essentially, this service is a completely separate resource. And what it's going to be doing is interacting with one of our pods because we want to expose that pod into our local environment. Now, how in the world is it going to know which pod it needs to interact with? Well, remember, we have given this pod a label of an app client. So the key is app and then the value is client. So what we can basically do is say, hey, you NodePort service, I want you to expose all of the pods with the app client label. We can have multiple pods with the app client label, but right now we only have one. And this is how we can basically connect a service to a pod. So that right there is what the selector is doing. So now let's start talking about the ports. The ports are pretty confusing, but hopefully I can kind of clear them up for you. So essentially what we're doing here, and we're really just going to be dealing with these two ports. This port is basically how we can get pods internal to our cluster interacting with other pods that contain this particular port. So let's just not worry about this for now. So right here, the target port is the port that is exposed inside of the container inside of this pod. And in a typical React application, by default, that is going to be port 3000. Now, what is this? So this is a special port that we only specify of type NodePort. And this is going to be the port that we are going to use to actually see our React application. So this is going to be 30,007. Now, for node ports, essentially there is a range that we can use. We can only use from range 30,000 to range 32,767. So we can't go any lower than 30,000, and we can't go any higher than this. So this is the node port. Now we're gonna get quite a bit of a funky URL here, but well, I'll show you guys how it will look like in a bit. So essentially we're gonna have something like localhost. And unfortunately I can't zoom in. So what I'm gonna do is I'll just write it over here. So we're gonna have a URL to actually see our React application. We're gonna have something like localhost and then colon 30007. All right, and this is pretty awkward, to be quite honest. This is pretty awkward because, well, when we want to go to a particular domain, we don't want to append this node port. We don't want to append this port. For instance, we just want to go to google.com if we want to go to Google. We don't want to go to google.com - this port. And this is one of the main reasons why we don't use node ports in production. Instead, we use typically an Ingress service, and we'll talk about that later, either an Ingress or a load balancer. All right, so that is pretty much it. So I hope that kind of makes sense. So again, what we're gonna do is we have this port at port 3000, and we're gonna be exposing this particular port inside of our local machine. All right, so I hope that makes sense. And now what we are going to do is we're going to apply this kubectl file, this manifest file right over here. So we're going to do kubectl, and we're going to do apply -f, and we're going to apply the client srv.yaml. And if we give that a quick second, you can see here that it has been created. A service has been created. So if we do kubectl get all, we should see we have a node port created right over here along with our running application. So now, do we have access to it in our local machine? Yes, we do. We absolutely do. So, but the way that we're going to have access to it is going to be different depending on whether you're using Minikube or Docker Desktop. If you're using Docker Desktop, you can just do localhost. So you can just do localhost. Let me just quickly. You can just do localhost - whatever that node port that you specified was. So localhost 30,007. However, if you are using Minikube, you're going to have to use the Minikube IP. So what you're going to have to do is you're going to have to write the command Minikube IP. And this is going to give you an IP. Now, I don't have Minikube installed, so I don't have an IP. And whatever that IP is, just replace localhost with that IP. All right, so now I'm using Docker Desktop, so I'm just going to cut this. I'm going to save this. And now what I'm going to do is I'm going to go over here, and instead of localhost 3000, I'm just going to paste localhost and that node port. And I'm going to enter, and there we go. We have our React application, and we have used a service to basically have access to it inside of our local machine. So this is a real React application. We can add habits if we want to. So add, maybe go for a run. So we can go ahead and add habits, we can change them. However, as you can imagine, if I refresh this, nothing is persistent. So we actually have to create our server and our MongoDB database. Remember, our server and our MongoDB database to actually persist this data. So let's actually do those in the next section. And in the next section, we'll actually have will actually be exposed to another type of service known as the ClusterIP, which is very, very important. So far in the course, we have created a React pod and we was able to access it through the creation of a NodePort service. And we were able to access it in an external fashion. However, sometimes we're gonna want internal communication between pods, not external. So how do we do that? Well, we don't do that with NodePort services. Instead, we do that with another type of service known as a ClusterIP. And that's what we are going to be talking about in this section. So a quick reminder as to how our current architecture looks right now. So far we have created our client pod and we have created this NodePort service right over here that allows our browser to communicate with this client pod right over here and have access to this client pod. And essentially this NodePort is allowing us to externally communicate from our browser to the Kubernetes cluster. However, we're going to want cases where we really don't care for external communication to that particular pod. For instance, we really don't care for external communication to this MongoDB pod. So we're really not going to assign a NodePort service for this MongoDB pod. Instead, we care about internal communication. So instead, what we want is we want our server pod to be able to communicate to the MongoDB pod that are both inside of the same Kubernetes cluster. Now, we don't do that with the NodePort service. Instead, we do that with the ClusterIP service, and that is the purpose of the ClusterIP service. ClusterIP service is used for internal pod communication, not anything external. That is up to the NodePort in development or the load balancer in production, or even the Ingress, which is used in both development and production and is actually the preferable method. And we're going to get to that actually a little bit later, so you don't worry about that too much. Alright, so far we have this structure right over here, but we haven't created our server pods and our MongoDB pods. We'll do that a little bit later. But then, once we create it, what we're going to do, just very temporarily, we're going to expose our server pods to our local machine, just so we can play around with it and use it. Really, what we're going to want to do is we're going to want to just expose this server pods to the client so the client can make a request to the server and then the server to the MongoDB database. But for now, just so we can play around with the server pod, we're going to create a NodePort service and we're going to expose it to our browser. And then after we do that, the very last thing is we're going to create a ClusterIP service for this MongoDB pod. And then any pod, any internal pod that wants to have communication with this MongoDB pod would then basically forward the request to the ClusterIP service, and then that would forward it to the MongoDB pod. Now over here, I have the server communicating to the MongoDB pod, but very similarly, if for some reason we want to do this, the client pod can communicate with the MongoDB pod by basically forwarding the request to the ClusterIP and then the ClusterIP to the MongoDB pod. Alright, so the first thing that we have to do is we have to create the server pod and the MongoDB pod. So let's go about doing the server pod first. Alright, so to do this, what we're going to do is we're going to create another file. We're going to call this serverpod.yaml. And this is going to be extremely similar to what we had before. So we're going to specify an API version of v1. We're going to specify a kind of pod. We're going to specify a metadata of name. And then we're going to call this pod, well, the server pod. And we're going to give it a label. Remember, labels are needed when we want to connect a service to a pod. So we're going to do app server. That's what we're going to give it the label. Again, the label can be whatever it is that we want as long as we're consistent. And then for the specification over here, we're going to define the containers, and then we're going to have the name of server, and then the image is going to be a lathe harb. This is an image that I have created and pushed to Docker Hub, and you should have access to it. dash server, and v1 is the version. So if we go ahead and we just do a quick kubectl apply dash f to the server pod.yaml, we should see that we have that created. All right, next step is let's create our Mongo pod. So we're going to call this Mongo pod. Now we're creating a lot of files here. It's probably not the best idea to create this many files, especially for all these resources. We'll talk about a better way to organize the file structure a little bit later. But for now, I'm going to separate the concerns just to kind of illustrate everything a little bit better. Okay, so over here we have an API version of v1, a kind of pod. This is getting a little bit repetitive. A metadata of Mongo pod. And then we're going to give this a labels. So remember, this is very important. We're going to give this app Mongo. And then for the spec, what we're going to do is we're going to define, of course, the containers that are going to reside within the pod. This is going to be an array entry. We're going to give the container a name of Mongo, and the image is going to be Mongo. So the image is going to be Mongo. And how do I get this? Well, I got this from, well, this Mongo image right over here. This is basically the default MongoDB image. So we can basically access that with, well, just Mongo. All right, so that's pretty much that. So let's just do a kubectl apply, and we're gonna do the Mongo pod this time. Terrific. Okay, so we have our pods created. So we are basically at this step right over here where we have our pods created, which is terrific. This is awesome. Now, what we want to do is we want to expose our server. So we want to expose our server to our browser. So we need to create a NodePort for this. So let's go ahead and let's do that right now. So how do we do that? Well, we would just say the server, and this is going to be the server service.yaml. And in here, we're going to have very similar configuration that we had with our client server, or service rather, sorry. Okay, so we're going to have an API version of v1. We're also going to have a kind of service. We're going to have a metadata, and this metadata is going to be of name server srv. Now, when it comes to the service, the name over here is going to start getting very, very important. So we can't really just put random names, and I'll show you guys why a little bit later. Well, you can put a random name, but whenever you want to access it, especially with a ClusterIP, you're going to be using this right over here. So this has to be a meaningful name. Now, if that doesn't make any sense, don't worry. We'll get to that a little bit later. All right, so we have the server srv. And then we are going to have the spec over here. We have to define the type as a NodePort service. Then we have to define basically, hey, what pods we are going to be essentially forwarding requests to. And this is going to be the pod with the app server label. So we're basically selecting the app server label. All right, so next step is to define the ports. This is going to be an array entry. Now, one thing that we can do is we also can specify the protocol if we want to TCP or whatever it is that we want to. I didn't do it in the last section because by default, if you don't specify it, then what happens is it just automatically does it by default TCP. Now, I'm just gonna do it just for documentation purposes, but really you don't have to specify it if it's gonna be TCP. All right, so the port is going to be 3000. Now, how do I know that the port is 3000? Well, a few reasons. Because I built the application. That's pretty much the reason. So you can see here that this is exposing port 3000. Now, one way that you can really tell is by doing a kubectl get all. Let's do a quick kubectl get all, and then you can basically access that server pod. So maybe you could do something like kubectl logs and then that server pod, and you can see here that is listening on port 3000. So that is one way, but really that's something that you would probably have a discussion with the developer. Now the target port similarly going to be 3000. Lastly, we need the node port. Remember, that's the port that we're ultimately going to expose, and it's going to be within a range of 30,000 to 32,000 and something, I believe. Now, we are already using 30,007, so we can't use that. So what we're going to do instead is we're just going to use 30,005. All right, and I believe that is 300,000. Yeah, that is 30,005. Okay, so let's go ahead and let's save this, and let's just do kubectl apply -f, and essentially now what we're gonna do, kubectl apply -f, and we're gonna specify the name of the manifest file that we want to apply. There we go. Now we have created it. So can we access this service through our local machine? Yes, we can. So to do that, all we have to do is do localhost 30,005. Now if we're using Minikube, it's going to be whatever that Minikube IP is. So you can see here that, well, it works. So you can see here that there is no route/get, and that's why we're getting this. But if you do something like /API, then you can see here that this is the Habit app API. So this works perfectly fine. And if you want to explore the API itself, it is written in Express and JavaScript. And you can see here it's a very simple API. We have this one route to /API. We have this other route to /post, and this other route to /get right over here. And this is getting all of our habits. This is posting habits and creating habits. All right. So let's actually do one thing before we create the ClusterIP service, because right now what we have created is this right over here. So we have created this, but now what we want to do is we want to create the ClusterIP service in order for our server to communicate with the MongoDB pod. So we have to create this. Now before we do that, let's actually go here and let's try to post a route. And you can see here that posting a route is only going to be done through MongoDB, because right here, you don't have to know MongoDB, just take my word for it. We are basically posting a route, and we need to have a connection to MongoDB done to do that. So just to prove to you that it is not going to work, what I'm going to do is over here, I have a post request, and this is going to be the rec.body, and I'm just going to go send this off right now. So I'm going to just send this off, and you can see that it hangs forever. Now it's probably not best practice that this hangs forever. The server wasn't built properly, really, to be quite frank. I really just built it very quickly because I wanted to explore Kubernetes over the server. But you can see here that it's failed because we don't have a connection to the MongoDB pod. Now let's create the ClusterIP, and then we're going to try that request again. So let's go ahead and create the ClusterIP. So Mongo, and this is going to be srv.yaml, and then we're going to create the ClusterIP. Now the ClusterIP is going to be still extremely similar to what we had before. So we're going to specify the API version of v1, the kind of service, the metadata, the name. Now the name is going to be extremely important here, and you can't just put in a new random name. Now you can, but you would have to again use this name accordingly, and I'll show you guys why in a bit. But I'm going to call this Mongo SRV, and then we're going to use the spec, and then essentially here we're going to basically define the selector. So this is going to be the app Mongo. So we want to basically have this service be attached to the pod with this label, which remember again we created right over here. Okay, and then the next step is to define the ports. Now one thing you may have noticed is that I forgot to assign the type of ClusterIP. And the reason for this is because if you don't define the type, then by default it is ClusterIP. Now I'll just leave it there for documentation purposes, but you don't have to really worry about the type if it is a ClusterIP. Okay, so now let's define the ports. Now the port is going to only contain the port, which is an array entry of course, and the target port. It is not going to contain the node port because we're not exposing this to our external environment. Now, what are these ports going to be? Well, they're going to be 27,017. How do I know that? Well, I just did a little bit of research, and this is the MongoDB default port. This is the port that it exposes. So if you're using something like Postgres, you would do a little bit of research, and you would figure out that it's 5,432, I believe. So it's really just dependent on how the pod was created. All right, so now let's create this over here. So let's do a kubectl. So kubectl kubectl apply, and we're gonna apply the mongo srv.yaml. Okay, so now that we have created this, what I'm gonna do now is let's just first double check that everything is there. So we're just gonna do kubectl get all. And so we can see here we have all of our pods running, as well as we have our cluster IPs, and everything is running perfectly. So let's try to do this request again. Hopefully this time it works. Sometimes there is a little bit of a lag, so let's just give it some time. Okay, let's try to send this off again. For some reason it isn't working, surprisingly. I am actually very surprised that this is not working. Okay. So why is that not working? So let's try to make this request again. There we go. Okay. So it's literally just, it needed some time to spin up. But you can see here, now it is working. Now it is absolutely working. So now we can do something like do my bed, or maybe like, I don't know, diet. Because, I'm starting to gain a little bit of weight. I want to diet. You can see here that this actually ends up creating, well, the service. Now, how in the world? So I created this service. Right over here. But how in the world are we basically telling our server pod to communicate to this cluster IP service? How is that done? Now, I'll show you guys how that's done in the next section, because there we're going to have to explore namespaces as well as DNS, as well as the IPs of these clusters. So I'll talk about that in the next section. So we have created all of our services right over here. However, I bet right now we're just questioning how in the world is this server pod communicating to the cluster IP and then eventually communicating to the MongoDB pod. Well, let me kind of explain that to you right now. So in the code, what we have is this line right over here, and this is the server. This is inside of the server, and this is the line of code that is going to we use to connect to the MongoDB pod. Now over here you can see here we're using mongoose, which is a library.connect, and here we're providing the URL path. So this right here, this first part is always going to be consistent, MongoDB : and this last part is just going to be the collection name. But whatever MongoDB instance that we want to connect to would be basically provided right over here with the URL. We created all of our services, but now we're just questioning how in the world is this server pod communicating with this cluster IP, which eventually communicates with the MongoDB pod. Well, let me explain that to you right now. The connection inside of the server is done through this line right over here, this line of code. So we're using mongoose to connect to our MongoDB instance, so mongoose.connect. And over here we have basically the URL that is going to define the MongoDB database that we want to connect to. Now, the first part of the URL is always going to be consistent regardless of whatever MongoDB database we want to connect to. So it's always going to be MongoDB : and the last part is just going to be the collection name. So you don't have to worry about this. But right here, the MongoDB URL, this middle part right over here, is going to be the unique identifier of that MongoDB database that we want to connect to. So what is that in our case? Well, in our case, this right here is going to be the IP of the MongoDB service, the ClusterIP service that we have created. So it's going to be that IP. All right, so just to kind of show that to you, let's just do a quick clear. And then we're going to do a kubectl get services. We're just going to get all the services. And let me just zoom out a little bit so it can be all in one line. You can see here we have all of our services. This is just the default Kubernetes service. And you can see here all of these have IP addresses. So right here we have, well, this address right over here. So this is the MongoDB SRV, and we have this address right over here. So really what we're doing is something that looks like this. So that is how we are connecting to this service, and then this service is obviously going to forward it to this pod. However, this is not really what we're doing. And the reason why we're not doing this is, well, let me show you. So I'm just going to keep this right over here. And let's say that something happens, and this can very well happen. Somehow, some way, this got deleted and needed to be restarted. So let's say kubectl, some sort of thing happened and it destroyed that particular service. So we'll do kubectl, and we're going to go ahead and delete the MongoDB. We're going to delete the Mongo service, and we have to specify that we were deleting a service. So we have deleted it. I hope we have deleted it. There we go. We have deleted it. Now remember, this is what the service, the cluster IP was before. Now let's go ahead and let's just recreate it. So we're going to apply -f the mongo srv.yaml. So now it is recreated. So now if I do kubectl get services, you can see, okay, well, this is the cluster IP. Now is this the same cluster IP? No, it's not. No, it's not. It is not the same cluster IP. And just to prove it to you, let's go back over here and let's just try to paste this somewhere over here, and you can see that it is not the same cluster IP. So every single time a service or a pod crashes, it's ephemeral. The things don't persist with it. It's gonna have a completely different IP address. And so we really can't connect in this way, because every single time our thing goes down, we have to reconfigure this right over here. So what do we do instead? Well, this is what we do instead. Instead, we use a hidden service that we haven't seen thus far, but this service does exist, known as the DNS service. And then this service is pointing to a DNS pod. And essentially, this pod is going to contain a key value store of the service name and its associate cluster IP. So right now we would do something like this. It would look something like this. We have the Mongo SRV, and it's going to be associated with this cluster IP. So that is what's happening here. Now, if this goes down for some odd reason and it comes back up, well, we're gonna have the Mongo SRV key, but then we might have a change to the actual IP address. So instead, what we do is we basically use this name and tell the DNS service to basically fetch whatever the value is of this key. So instead, we use this right over here. So instead, it's going to be Mongo SRV, which is exactly the name of the service that we have specified. So now the Mongo SRV inside of this pod right over here is going to have a key value pair, and regardless if this is changing, this is always going to be consistent. And that's great, because this is also always going to be consistent. And that's why if you go to our code, you can see here that I'm using Mongo SRV, and that's why it actually worked automatically. So I hope that makes sense. Now you might be wondering, okay, well, I kind of get that, but I've never seen this service, as well as I've never seen this pod. So when I do a kubectl, let me just quickly clear that. And let me do a kubectl get all. You can see here that, okay, well, I see all of my services here. I see my pods. I don't see that service that you're talking about, that DNS service. And that's because it lives under another namespace. So namespaces is something that we're not going to cover extensively in this, but it is important to understand. Essentially, if we have many pods and many services and many resources, what we ultimately might want to do is separate them into different concerns. For instance, if we have a lot of services and resources associated with our client, we might want to put it in the client namespace, and we can create a namespace if we want to. Now, if we want to have a lot of resources associated with our server, then we want to put that in the server namespace. And that way we can basically separate our concerns a lot easier, especially when we're dealing with a lot of different resources. So you can really think of namespaces as folders that allow us to organize all of our resources. So by default, we actually have quite a few namespaces. So we can do a kubectl get namespaces, and we can see all of the namespaces. We have the default namespaces. You might not have the Ingress Nginx, but you can see here that we have the kube namespace, we have the kube public namespace, and the kube system namespace. So right there, that is a bunch of namespaces. And now when we do a kubectl get something and not define the namespace, it always deals with the default namespace. So when I do a kubectl get all, it gets all of these services in the default namespace. If I do a kubectl apply whatever, then it applies it to the default namespace. However, if we want to get resources inside of these other namespaces, then we actually have to define the namespace. So we can basically say kubectl get all and then -n for namespace, and then define that namespace. So over here, we're going to look at the kube system namespace. So let's go enter that, and you can see here, well, we have that kube DNS that I was talking about. It is right over here, and it was all hidden from us. And then over here, we can see that we have the DNS pods right over here. And that is basically where all that key value pair lies. Now, in the remainder of this section, because we literally just have a few resources, we don't have a lot of resources, we're just going to be working with the default namespace. But that is just something that I wanted you to understand. So hopefully now you have an idea as to how we basically have this communication. And that basically shows how important this name is. Because if I were to change this name to like this, for instance, then that key value pair, let me change it to something smaller, like just Lathe. That right there is going to be the key right over here, and then consequently we would actually have to change that inside of our code. So we would have to basically change that. If I go right over here, we'd have to change it right over here. This would have to be Lathe. And that is how we basically communicate with our ClusterIP. So I hope that makes sense. You got a good idea of how networking works in Kubernetes, as well as I introduced you to namespaces. So that's awesome. Let's actually move on to the next section where we're going to talk about another resource type known as deployments. Time to introduce another very important resource type known as deployments. And to explain deployments, what I'm going to have to do is we're going to have to look at how we have been creating pods thus far. So when we ever wanted to create a pod, all we would do is we would basically specify the pod that we want to create, the manifest file, and it would go ahead and create that pod for us. However, if that pod goes down or it gets deleted, we would have to manually reapply this pod configuration. For example, let's look at the server pod. So let's do kubectl get all. Let's wait a little bit, and there we go. We have gotten them all. And let's say that this pod goes down, or it has crashed, or we have accidentally deleted it. So kubectl delete pods, and we're going to delete the server pod. Now, if I do a get all on that again, so if I do a get all on it again, and not now, please. If I do a get all on it again, then you can see that this pod is completely gone. It is not there anymore. However, we probably want our pods to spin back up automatically if it crashes or it gets deleted. So that is something that we probably want. Right now, we would just have to do a kubectl apply-f of the server pod.yaml. So we would just go ahead and do that, and now it is up and running again. But again, we want to automate this process. If we delete this, or if this crashes, we want to go ahead and spin it up. Another thing that we might want to do is if we're getting a lot of traffic, we might want to automatically just replicate the amount of pods that we have. We want to horizontally scale the amount of pods. So this might be another thing that we ultimately want to do. And how do we do that? Well, we could do it manually again, but that is pretty difficult. A much better approach is to define a separate resource that is going to be in charge of running the pods. So typically, we never define the pods on their own. Instead, what we define is a deployment. And a deployment is basically going to be a resource that is going to be in charge of pods and is going to be in charge of maintaining a set number of pods. So what we are going to do is we're going to define a deployment, define the pod that deployment is in charge of, and define the desired state of that pod. So the desired state could be we always want 3 of that pod running or 1 of that pod running. And what the deployment is in charge of then is basically looking at the desired state and looking at the existing pods that it is responsible for, and essentially trying to ensure that, hey, the desired state is always met. So if the desired state is to have 2 server pods up and running, and then 1 of them gets removed, then the deployment server is going to be in charge of spinning that up again, and it will do that automatically. And that's why we always have our server deployment instead of pods. We never really create pods on their own. We create deployments that are in charge of pods. So let's go about creating the deployment right now. And we're going to start off with the server pod. So we're going to start off with the server pod. So the first thing we're going to do is we're going to not define pods anymore. We're going to define deployments. So let's just change this to server-depl, which stands for deployments. Now, this configuration is still very important because we're going to define the pod inside of the deployment, but I'm going to just comment it out for now. So just quickly comment it out for now, but we still do need it. Okay, so now let's start defining the deployments. So to define the deployments, we need to specify the API version. The API version is a little bit different, so it's going to be /apps/v1. The kind of resource that we are defining is a deployment, and then we have to have some metadata for that deployment. This is going to be, well, the name. We're just going to call this server-depl, which is deployment. Now we're going to define the specification for the deployment. Remember, this line right here is for the deployment. So I'm going to quickly just comment that right in there. So spec for deployment. So in here, we're going to define one thing, and this is going to be a little bit different. This is going to be defining the replicas. And basically the replicas is how many replicas of the pod that this deployment is in charge of do we want up and running. Now typically it is usually 1, but we could specify 3 if we want to. In this case, let's actually leave it at 3 just so we can see how it looks like. Alright, and then the next thing is the selectors. And in here, we are going to basically match the labels of the pod to that selector. And this can be a little bit confusing because the pod is going to exist in the same file right over here. And it can be a little confusing, but again, we're creating a completely new resource type that is in charge of another resource type. So we have to link those together through labels. Now, the way that we do it is a little bit different than the way that we have done it in services, because we would just do selector and then we would just specify the key value pair. There's just a little bit of an additional step. It is instead going to be match labels match labels, and then we're gonna do app server. So map server. And the reason why we have to do match labels is we can actually have multiple different ways that we can select a specific pod. So in this case, we're just going to do the match labels way. All right, the last thing is inside of here, we also have to define the template. And the template is basically the pod that we're trying to create. And so it's going to contain the metadata as well as the spec. So let's go ahead over here and let's just cut this out. And let's just paste it right in here. And let's just uncomment it. Tab, and then, well, let's go back one. There we go. So this is how it is going to look. However, inside of the template, we're always going to be defining pods. So we do not put the API version or the kind, because it's always going to be a pod. And there's really no point of specifying that. So over here, we have the metadata of the pod as well as the spec for the pod, not the deployment. So I hope this makes a lot of sense. I know this can be very, very confusing. So let me go ahead and let me just say that this is the spec of the pod. Okay, so just I'm going to quickly reiterate through this. Deployments are kind of confusing. I 100% understand that. And you might need to go through this a few times to truly understand it. But again, we're specifying the API version, we're specifying the kind, which is deployment, and then the metadata for the deployment. And then this is the specification for the deployment. We have replicas, and then we're basically matching the deployments to pods using the match label selector. And then the template is basically the specification of the pod that we're trying to create. So over here we have the metadata of the pod along with its label and the specification that contains the container. So I hope that makes sense. We're going to go ahead and run that very, very quickly. Now before we run it, what I'm going to do is I'm just going to do a kubectl delete, and I'm going to delete all. So I'm going to delete all of the resources inside of our cluster. So it seems here that this is not working, and that's because I forgot it's 2 dashes actually. So now we're deleting all of the resources inside of our cluster. Now that is going to take a little bit of time, so let's just wait that out. And now what I'm also going to do is for each deployment, we're going to create pods, and for each pod, we're going to need a service to expose it in some way, whether it's a NodePort or a load balancer or a ClusterIP. So instead of creating 2 separate files for the server DEPL and the server service, what I like to do is I like to put this all in one file. So this over here, I just like to put it in the DEPL because we always have a service with a deployment. Not always, but most of the time we will have that. So to do this, we can definitely specify 2 configurations in the same file. However, we would have to separate them with a dash, dash, dash. So 3 dashes. So here we have the deployment, and here we have the service. So if I were to do kubectl -f server DEPL, it's going to create the deployment as well as the service. So now we really don't need this anymore. So we can just go ahead and delete it. So we can go ahead and delete this. So let's move it to the trash. All right, so let's just now actually apply this, and then later on we'll actually work on the other ones. So let's just do a quick kubectl get all, and we should get all of them, and we don't have nothing other than the default service. So now let's do a kubectl apply -f, and we're going to apply -f the server-depl.yaml. So let's do that. So it has created the DEPL and has also created the service. So now if I do a kubectl get all, you can see here that we have a bunch of things running. So the first thing that's running is 3 instances of that server pod. So here we have our pods, and it's running 3 instances of it. And that's because we have specified 3 instances. It also created the service, which makes sense. That was the other config file. It also has created the deployment, and it says that 3 out of 3 are up and running. And it also created another resource type known as a replica set. And a replica set is a resource type that is going to help out and it's going to perform some of the actions that we have performed here. So it's going to basically create 3 if we want to, and if we end up deleting it, it's going to go ahead and save it or spin up another instance. So this is what the replica set is for. Typically, we create deployments because they end up creating the pods as well as the replica set, so we never really deal with replica sets. But if you are interested, go ahead, read some documentation on it. Okay. So now let's actually look at something interesting. Let's say I go ahead and I delete this pod over here. So let's do kubectl, and I want to delete this pod. So pods, and I want to delete this pod. So let's give it some time. It has been deleted, which is terrific. So let me just quickly exit out of this, and let's do a kubectl get all. So you can see here that this has been terminated, but then it was like, okay, I'll just go ahead and spin up another one. So now we're always going to have a desired state of 3. Let me see if I can just do this really, really fast so that we can actually see that the desired state to be 2. So kubectl delete pods, and we can go ahead and delete this. And then quickly, oh my goodness, this is not quick enough. Let's see, hopefully we can catch that. Oh, there we go. Awesome, we did catch it. So you can see here that, okay, this is, so 1 got deleted. And now you can see here that it's 2 out of 3. So now the deployment is basically unhappy, but over time we're going to basically try to satisfy the state. So you can see here now it is happy, and now it's because we have 3 running pods. And this is great. So if this ends up ever crashing, then that's all good. It's going to go ahead and just create the pods again. And you can see here that this pod has a smaller age than these other ones because, well, this one was spinned up again. All right, so that is pretty much that. Let's actually go ahead and let's create the pods or deployments for these ones over here. Because again, we always want to have deployments instead of pods. So let's do that right now. Let's go to the mongodb.pod and let's create the deployment for it. So over here, we're gonna have the API version, and this is going to be of apps v1. We're going to have the kind of deployment. We're going to have the metadata. And this is going to be the metadata of the deployment, which is name mongo depl. And then we're going to have the spec for the deployment. Let's have a replica of 1. And similarly over here, let's change this back to 1. It was just for demonstration purposes. Where we go? Here we go. Let's just change this back to 1. We don't really need 3. So let's save that. Okay, so now over here we're going to do the selector, and we're going to match labels of app mongo, and then lastly we're going to define the pod itself that this deployment is in charge of inside of the template. To do that, well, you would just do this right over here. Okay, cool. So that right there is pretty much that. So now what we can do is we can basically get the service over here. Let me just copy this, and let's actually paste that in there as well so we don't have multiple files. There we go. Terrific. Let's rename this to depl. So we're going to rename this to depl, and we're going to delete this service. So we're going to delete this service. Okay, cool. So now we have to do the client. I highly encourage that you try to do this on your own. But what I'm going to do now is I'm getting a little bit lazy. So I'm just going to copy this part right over here, go to the client, and then just paste that in there. So I'm going to get rid of the API version and the kind, just paste that in there, and then just tabulate this accordingly. Now over here, I'm just going to change this to client, and I'm going to change this to client. All right. Now for the service, we're gonna basically cut that out, and we're gonna go ahead and do dash dash dash. We're gonna spin it up like that. So now we can basically save all this, and we can delete this file as well because we don't need it anymore. Just move that to the trash. All right, so we basically have all of our deployments. Let's go ahead and apply them now. Now we could apply them one by one, but a better way of doing it, if you want to apply all of the YAML files, is to do kubectl apply-f, and instead of specifying the name, we specify the directory where all of our YAML files are. And basically what happens in that case is it's just going to apply all of the YAML files in that directory. Now right here in the terminal, we're in that same exact directory, so we can just do dot. And there we go. We can go ahead and apply that. And you can see here that it has created the client DEPL, the client server. It has also created the Mongo DEPL and the Mongo server. And it has configured the server DEPL. So because we configured it, basically means that it has edited it. Because remember, we changed it back from 3 to 1. And over here, this was completely unchanged. So now if we do kubectl get all, give it a little bit of time. Hopefully it doesn't freeze on me, and it didn't, which is great. You can see here that we have all of our these are our deployments. We have our running pods right over here. We have all of our services, we have deployments, and we have our replica sets. So that right there is deployments. And again, we always create deployments and not pods because we want to have that automatic change in case of some sort of change that is not desired. We want to basically Kubernetes to automatically do this, as well as we want to specify how many replicas we want a lot more easily. So we always really deal with deployments. So that right there is basically this. Now I just noticed here that I'm gonna just change this over here to deployment instead of pod, but it's fine. It has configured it appropriately anyways. Okay, so that is deployments, and that is really, really great. That is really, really great. Now the next step is to look at another service known as Ingress. So we talked about this a little bit later, but now we actually want to use the Ingress service. We talked about this a little bit before, but now we're going to really dive deep into it. And this is known as the Ingress resource type. And this is a way that we can basically network our Kubernetes cluster in a little bit of a better way than we have been doing it thus far. To kind of illustrate how we have been doing it thus far, our application kind of looks a little something like this. So we have our browser, and in order to get access to our client, we have a load balancer. Now again, in our development environment, this is a NodePort, but in production, it's going to be a load balancer. So I just changed it to a load balancer. So we would just go ahead and we would access our client pod with this load balancer service. However, if we wanted to have access to our server pod, then we would have to configure another load balancer. Now, as you can imagine, if we get thousands of pods that our browser needs to have access to, then we would have to create, well, thousands of load balancers. And this is kind of annoying, and it's also not that great. So instead, we can actually solve this problem with the Ingress resource type. And how does it solve it? Well, it changes the architecture to something like this. So now all we have is one load balancer, and we always are going to forward our request to the Ingress resource type. And then the Ingress resource type is going to read that request, and then it's going to have a set of rules that it's going to follow. And then with that rules, it's going to essentially distribute it to the correct pod. For instance, if I make a request like habittracker.com, basically saying, hey, I want to see the website itself. Let me just go ahead and increase the size of this. I want to see the website itself. Then what's going to happen is it's going to basically, the Ingress is going to get this, and the route rule says, okay, if this doesn't have any slash or anything appended after it, then go ahead and forward this to the client pod. If there's nothing after this, it's going to go ahead and append it to the client pod. However, if I want to basically access the API, so like API-habit or whatever, then it's going to basically read that rule. It's going to say, oh, this actually hasn't /API, so we're going to forward this to the server pod. And this is a lot better. This is much, much better. And the reason for this is because now we don't have to configure a bunch of load balancers, as well as this is going to be exactly the same environment in production as it is in development, which is terrific. We always want to have similar environments in both development and production. So I hope that makes sense, and let's actually go ahead and start creating this resource type right now. Now, to create this resource type, it is a little bit complicated. So what we're gonna have to do is we're gonna have to go to Ingress Nginx to create a bunch of resource types associated to this Ingress type right over here. Now to find this, just go to Google and just click or just search Ingress Nginx. So Ingress Nginx right over here. And then what we're gonna do is we're basically going to click right on this page over here, kubernetes.github.io. So once we click on this, then we're gonna go to this page right over here, and then we're gonna go to deployments. So in order to create this resource, there is a mandatory command that we have to execute. And this command is going to be different depending on the environment that we're in. I'm using Docker Desktop, but you could be using Minikube. So if you're using Minikube, click on this. And if I'm going to click on this because I'm using Docker Desktop. Now you could also be using a cloud provider like DigitalOcean or Azure or AWS or Google Cloud. So you might want to basically click on this if you are in a production environment. Right now, I'm going to click on this right over here. And this is the mandatory command that I need to execute in order to run that Ingress resource type. Okay, so what is this command? Well, this command looks like, well, a kubectl apply command that we have been doing thus far. So let's see here. I'm going to just copy this, and this seems to be an HTTP link. And I'm just going to paste it right in there. And you can see here that this is just a bunch of YAML configuration. So over here we have a namespace that we talked about. Over here we have a config map that we will talk about, and just a bunch of different resource types that are needed to run that Ingress resource type. And that's basically what we are doing right here. Now if you're on Minikube, this is basically an extension, so you would just, or an add-on, so you would just enable that add-on. So you can just click on this command. So I'm going to go ahead and just paste this in here and just wait a little bit. And you can see for me, everything was unchanged because I've already created all those resource types before. But for you, it might all be created. So once that's done, we can actually go ahead and start creating this right over here. And how do we do that? Well, we create it with manifest files, of course. So let's create the Ingress and then the Ingress srv.yaml. Okay, so the Ingress service.yaml. So the first thing we have to do is specify the API version. This is a little bit weird. It's going to be extension-v1-v1 beta 1. And then we're going to have a kind of ingress. We're also going to have a metadata. And this metadata is going to contain a name of Ingress service. And then we're going to have something else called annotations. And in the annotations, we're first going to say that, hey, this Ingress service is an Nginx Ingress service. Now we do this with kubernetes.io-ingress.class.nginx. Now this is, I know it's super strange, really strange, but don't worry all too much about it. This is basically saying that the Ingress service is using Nginx. And later on, once you have done this, you can just literally just copy and paste this. So you don't really have to remember this. The next thing is that we want to be able to set regex rules inside of our Ingress service. And the reason for this is because what we want to ultimately do is anything that has /API in it, whether it's /API habits, /API bananas, /API whatever, we want to forward it to the server pod. But then if it's just a slash or /anything that does not start with /API, we want to forward that to the client pod. And the only real way we can actually set up this rule is by using regex. If you don't understand regex, don't worry all too much about it. I highly suggest maybe reading a little something about it, but you'll see it in use in the rules in a second. Now to say that we want to enable regex, we would do nginx.ingress. So nginx.ingress.kubernetes.io-use regex, and we're going to set this to true. So please, if you're following along, make sure that everything is typed in properly. This was a very kind of complicated set of lines that we have done. Okay, so now that is out of the way. Now let's define the specification of the Ingress service. And in here, we're going to define the rules. So in here, we're going to define the rules. So the first thing that we're going to have, and we can have multiple rules, so this isn't going to be an array entry. And so the first thing that we're going to have to provide is the host. Right now, the host of our application is localhost, and unfortunately, we can't use localhost on our as our host in the Ingress Nginx service rules. So we actually have to use a real domain name. So we can either register a domain name, or we can basically trick our current machine right now. We can trick our current machine right now, basically saying that, hey, this is a domain name that we're using, but really just link it up to our local host. Now, how do we do this? Well, to do this, what we would do, if you're on a Mac or Linux machine, you would just go to your terminal and you would open up a folder called -etc-hosts. So -etc-hosts. So you can see here that this opened up this right over here. And you can see here that this basically is the localhost API, and it's linked to localhost. So now what we can basically do is we can basically copy this down. We can go over here and we can basically change this to, let's say, habittracker.com. So habittracker.com. So now whenever we go to habittracker.com, it's going to go to this localhost IP. So let's go ahead and let's save that. And we're gonna have to save this as sudo. So we're gonna go retry this, and I'm gonna have to put in my password to my actual machine. So I saved that. So now we can actually use this. So we can actually go ahead and use this host, and we can basically trick our Ingress service to say that, hey, this is the domain, but really is connected to our local machine. Now, if you're on Windows, the step to get to that etc folder is going to be a little bit different. I'm not on a Windows machine, nor do I have the ability to record on a Windows machine. So what I'm gonna do is I'm gonna show you the steps that you have to take to get to that folder. So the first thing you want to do is you want to go to that start button, and you want to run it as an administrator. So go to the start button, write command prompt, right click on it, and run it as an administrator. And then move into the Windows System 32 driver-etc folder. So move into that folder, move into that directory right over here. So when you're running as an administrator, you're probably going to go to Windows/System 32. So then you would just cd into drivers and then cd into etc. And once you cd into that, execute this command in the terminal, notepad hosts, and that should open a notepad instance that looks very similar to what we have over here. And then you would just do the exact same thing right over here. Okay, so I hope that makes sense. So that is what we are basically doing. Terrific. All right, so now that we have that, let's actually go ahead, let's close this up. Let's set up our routing rules. So the first thing we're gonna do is we're gonna say HTTP, because this is going to be HTTP rules, and then we're gonna specify the paths. So this is going to be an array entry, and we're gonna say firstly, the first path is if it goes to /API/ and then here's where the regex comes in, /anything else. So this is basically saying, that, hey, if the path is /API/anything else, this is basically how we define anything else, then what I want you to do is I want you to forward this to the service that we have created, and this is going to be the service in charge of the server pod. So we want you to forward this request to the service that is in charge of the server pod. So now basically what we want to do in the server pod, I know right now we have a NodePort, so we have a NodePort in the service pod, but we probably don't want this anymore. We actually want to use a ClusterIP, because now all the communication is internal. So let me just quickly illustrate that. All the communication is going to be internal. So we can basically get rid of this if we want to. And so we want to basically forward this to this right over here, the service SRV. And remember, if it forwards it to the service SRV, then it's ultimately going to forward it to the pod itself. So to do that, we will basically say backend And then we basically want to say, we want you to forward this to the service name of service SRV. And then we want to specify the service port. And this is, well, 3000. So remember over here, 3000. Okay, so that is the first rule. And now the second rule is, well, let's define the other path. So the path is going to be, well, if it is just slash and then anything else, so if it's slash and anything else that is not slash API, because slash API is going to be hit first, then we want you to forward this to the backend, and this is going to be the service name of the client SRV, the client SRV, and then the service port. So the service port of 3000. Okay, so now let's actually go back to the client service, and let's change this to a ClusterIP, and let's get rid of the NodePort right over here. Okay, that is terrific, and that is pretty much it. And now we have set up the routing rules. So one thing that we want to do now actually is we want to go to the client, and I want to change this version to version 2, because this is the version that actually utilizes that that Ingress service, because before it wasn't utilizing it. So let's just change this to version 2. All right, so that is terrific. That is pretty much it. So now what we can basically do is we can apply all of this. So let's do kubectl. Let's just do a quick clear here. Let's just do kubectl apply -f and then dot, all the files in the directory. All right, so we have configured. Some of them were unchanged because we didn't really do anything with the MongoDB. Unable to recognize a no match kind in version. Okay, so this hasn't worked. So let's actually try to fix this up. And the reason for this is because this is, apologies, is going to be extensions, not extension. So that's why it can't find it. So let's save that, and let's go ahead and let's apply this again. So over here it's saying, okay, unknown spec, and the reason for this, again, my goodness, this is supposed to be not inside of the metadata. It is supposed to be outside right over here. So hopefully you caught that. Sorry, things can get a little bit tricky when you're creating all these files. So again, we got the API version. This should be extensions, and then the spec shouldn't be inside of the metadata. And that kind of illustrates how important the indentation is in YAML files. So hopefully there's no more errors. Let's do kubectl apply. And we are still getting some more errors. So unknown field spec. Off camera, I was scratching my head wondering what in the world is wrong with this config file, only to realize that I did not save this. So please remember to save. And then once you save, just apply this over here. So kubectl apply -f dot. And then once you do that, you might have to wait a minute or two. You will be able to go to habittracker.com, and you should see the application now. Now, if you see some sort of error page saying that, hey, this is not secure, that's only because we are using HTTP instead of HTTPS. And this makes sense. We obviously don't have an SSL certificate. To get around it, anywhere on the web page, just click anywhere on the web page and just type "this is unsafe." Without any spaces, just "this is unsafe," and then you should be able to see this. Now, I see this because I've already typed it a million times before. And if you don't see it, that's great. So now you can see that we have our application, which is terrific. So right here, if I do something like /this, it's always going to just forward it to the React app. If I do /API, however, you can see that it forwards it to the API instead. And you can see that now our Ingress service is working the way that we have specified it, which is terrific. So now what we can do is we can go ahead and let's add a habit, a new habit, whatever. And now we can save this habit. You can see here, we can save that. And what's great about it is if I refresh this, that habit persists. And the reason for this is because this is stored in our MongoDB database. Now, let's say we run into a problem. Our MongoDB database goes down. Let's say that this happens. So let's do a quick kubectl. So let's do kubectl get the pods. So remember, our MongoDB database is going to exist in this pod over here. And let's say this goes ahead and it crashes. So it crashes. So let's simulate this by doing kubectl delete pods, and we're going to delete this pod right over here. Now, what's great about this is now essentially what's going to happen is our pod is going to get up and running again. So now we have a different pod. So to kind of illustrate this, remember this was our pod before, and you can see that the identifier is a little bit different. You can see here it ends with 2K. Over here, this one ends with 2PV. And so this is a completely different pod, but our deployment created that because it was deleted. However, now if I refresh this, our data is gone. Our data is completely gone. And I'll talk a little bit about why this is in the next section. And we're going to talk about how we can actually persist data in that section as well. We finally got our application up and running, but we noticed a problem. If our MongoDB pod goes down and then gets restarted again, our data does not persist. And that is a very huge problem because we have to 100% assume that our MongoDB pod will crash eventually and need to be restarted. So how can we persist our data knowing that our MongoDB pod will eventually crash? So before I explore some of the options that we have, let me tell you why we don't persist our data if our MongoDB pod crashes. So over here, I have our MongoDB pod, and in here, of course, we have our MongoDB container. And inside of the container, we have a bunch of files and folders within it. And particularly, we have a directory /data/db that is very particular to MongoDB, and this is exactly where all of our data is being stored. So if I were to add a habit, it would store it over here. If I were to add another habit, it would store it in that exact same directory. And if I ever want to basically request data, well, that data will be located here. Now, if that container goes down and needs to be restarted, however, what ends up happening is it restarts the container in a completely blank slate. And all the data that we had in there are completely gone. And that's exactly why when this pod crashes, or a container in this pod crashes, we lose all of our data. So how do we fix this? How are we going to fix this problem? Because we, again, 100% have to assume that this pod will eventually go down. So how do we fix this? Because persistent storage is very important. Well, one way to fix this is through something known as a volume. So essentially, in a volume, what we can basically do is external to the container, we can have some sort of storage external to this container. And every single time we want to add data into this container over here, we want to add data, we also add it into the storage. So we add it into this storage over here, and basically this directory over here is mounted to this external storage. So this directory is mounted to this external storage, so it basically has access to all this data. And this external storage is located inside of the Mongo pod, but outside of the container. So if the Mongo container ever crashes, and has to be restarted again, that is completely fine, because now it can just get the data from this external storage inside of the pod. Now, you might be noticing a problem with this, and it is a huge problem. What if the pod crashes? And if the pod crashes, then we lose all of that data inside of this external storage because this volume is located inside of the pod itself. So this is not a very good solution. Yes, you know what? It protects against the container crashing, but it doesn't protect against the pod crashing. So this is not a very good solution. Let's find another solution. Well, another solution is a persistent volume. And this is where the storage is located external to the pod. And so essentially now what we can do is when we want to add something to it, well, we add it to this storage, and then this directory over here is going to be mounted to the storage, and therefore it's going to have all that data. Now, if the whole pod crashes, completely fine. That is okay. We can just spin up another pod and our data will still be located in this storage right over here. And this is, well, the ideal way of doing things, especially when it comes to databases. So that is what we are going to be doing. However, we're going to be doing something known as a persistent volume claim. And a persistent volume claim is not really a way of storing data. So over here we have a way of storing data. Essentially, a persistent volume claim is a way of asking for a persistent volume. So for instance, right over here, we have basically three options. We have three options over here. We have either 1 GB of storage, 2 GB of storage, or 3 GB of storage. And these right here, these options are persistent volume claims. So they're just options that we potentially have. And essentially what happens is these options are here, and then we would have to go ahead and ask for an option. So I can say, oh, I want 1 GB of persistent volume for my MongoDB container. And essentially what Kubernetes will eventually do is create a persistent volume, and it's going to figure it out somehow. It's going to be like, okay, well, you want this 1 GB right over here, and you want a persistent volume, so it's going to create this persistent volume over here, and of course mount it to the MongoDB container. So essentially what we're going to do is we're going to create persistent volume claims, which are a bunch of options that we potentially have for our Kubernetes cluster, and then we're going to basically pick whatever persistent volume claim that we want to use for our container. So that is what we are going to do. And let's actually go about doing that right now. Okay, so let me just quickly zoom in a little bit here, and let me just do a little bit of a clear. There we go. Okay, so now what we're going to do is we're going to create a persistent volume claim. So Mongo, and I'm going to call this PVC for persistent volume claim. And this is a Mongo persistent volume claim, so we'll leave it in here. So the first thing that we are going to do, let me zoom in some more here. The first thing we're going to do is, of course, API version, which is V1. The second thing is kind, and this is, well, going to be a persistent volume claim. So this is the persistent volume claim. The second thing we're going to specify is the metadata. Now the metadata is just going to have a name, and we're going to call this Mongo persistent volume claim. All right, now we need the specification of that persistent volume claim. And this is where it gets a little bit interesting. The first thing that we're going to do is the access modes. So the access modes, and this is going to be an array entry, and we're just going to specify read write once. And apologies, oh my goodness. And this also has to be a capital right here. So read write once. Now, what does this mean right over here? Well, if you go to the official documentations of Kubernetes, you can look at all the access modes. Basically right here, we have 3 different access modes. So read write once is so the volume is mounted as a read write by a single node. So we can read and write data from a single node. And this is basically what we want, because our pod is always going to be on one node, because we're only going to have one replica of it anyways. But if you want other options, so read only many, so the volume can be mounted and it can be read by many nodes, that is definitely a possibility. So you could actually add this. If you want many nodes to be able to read from our volume, you could also add this. However, I don't really want that. And then we have read write many, so the volume can be mounted as read write by many nodes. So over here, you would either pick one or the other. As if you want your volume to be mounted and read and written by many nodes, then you would use this over here. Okay, so I hope that clears that up. So that is the access mode, and then we're gonna basically, well, define the resources over here. So remember, if I go back here, this is not storage. This is basically a bunch of options that we have, because this is each one of these is a persistent volume claim. So we're going to basically say that, hey, I want to choose this option, or I want to choose this option, and I want to choose this option. So as you can see here, this option has 1 GB of storage. This option has 2 GB of storage. This option has 3 GB of storage. So what I'm going to do is I'm going to say, okay, I'm going to create the options, and I'm going to basically define the resources for each option. So the resources, and I'm going to basically request, and I'm going to request a storage of 1 GB. Now I can create multiple persistent volume claims. I'm just going to do one for this case, but I can very easily create multiple persistent volume claims, maybe give this another name of 2, and then I can do another one of 3. And then I get to pick which option from my container. We'll see how we can pick them right now, actually. Alright, so now that we have created the persistent volume claim, now let's actually go about using it inside of the MongoDB container. Okay, so remember, the MongoDB container is going to be resided in the MongoDB pod, which is basically right over here. This is the specification for the MongoDB pod. So the first thing that we have to do is inside of the MongoDB pod specification, we have to define all of the potential volumes that we are going to be using. And we can use multiple different volumes, but now we're only really going to be using one. So let's just define all of the volumes, and this is going to be an array entry. And we're going to call this volume, well, Mongo storage. So that's what we're going to do. And then what we're going to do is we're going to, well, define the actual volume. Now the volume is coming from, well, the persistent volume claim. So we would just say persistent volume claim. And then we would do claim name. And this claim is going to be basically the name right over here that we have specified. So we can basically copy that name, and then we can just paste that in there. So this right here is basically saying, okay, well, these are some of the volumes that are located in the MongoDB pod. These are some of the options that we have. However, now we need to actually allocate it to the MongoDB container. Well, to do that inside of the container level, what we basically do at this point is we just say, hey, we want to mount this volume. So volume mount. And this is going to be mounts with an S because we can have multiple mounts. And we're going to say the name of the volume that we want to use. Now, the name is going to be identical to the volume name that we have created right over here in the pod level. So then we say Mongo storage. And then, very importantly, we basically have to define the path where we want that data to be mounted to. Now, what is that path? Well, it's going to be very dependent on the database that you're using. But in MongoDB, the path is /data/db. How did I figure that out? I literally just researched it up. So that's basically how you would figure it out. It would be probably a different path for a Postgres container, a different path for a MySQL container. So we would say host path. And basically the host path is going to be /data/db. Okay, so that is pretty much all that we really have to do. So let's actually go ahead and let's do a kubectl, and we're gonna apply everything. So I'm just gonna kubectl-f apply. So hopefully no problems are arising, and there is a problem, of course. So we have some sort of error here. So the DEPL unknown field host path, and that is because, let me see here, unknown, where is this host path? Okay, so this is, so it's failing right over here, and of course it's not host's path, apologies, it's mount path. Apologies for that, hopefully you guys caught that, or if you didn't, it's mount path, it's not host path, sorry. So this is basically the path that we actually want to mount inside of the persistent volume. Alright, so hopefully that's okay now. So if I do okay, so it seems like everything has been created. Its persistent volume P is invalid. The only reason why I got this error is because I have already created a persistent volume like this, and I had it at 2 GB. So I basically just changed it to 2 GB. But high chance that you probably are not getting this error. Okay, cool. So that is pretty much it. So we have basically configured our persistent volume, which is pretty great. So now if we do a kubectl get all, we should see, well, of course, all of our resources, all of our replica sets, as well as our deployments and our services and our, well, pods. But we don't see our persistent volumes. To see our persistent volumes, just do kubectl get pv, and you can see here that we have one persistent volume. So let me just quickly zoom out of there a bit, just so we can see the table a little bit better. You can see here that the capacity is 2 gigabytes, which is terrific. And then we basically have a status of bound, which says, hey, I'm being used. And then we have basically, well, the claim that it's using. So remember, the persistent volume is the actual storage location. So this is the persistent volume that was created from our persistent volume claim. Now over here we have something called storage class, and I'll get to that in the next section, so don't worry about it. But right now you can see that it says host path, which is cool. So okay, so that is pretty much this. So and then basically right here it's using the persistent volume claim that we have created. Now to see the persistent volume claim, you can just do kubectl get pvc. And then this is the persistent volume claim, the MongoDB. You can see that it's bound. We can see the volume that's associated with it, and we can see the storage class. The storage class is very, very important, and I'll get to that in the next section. But now let's see if it actually ends up working. So let's go back to our React application, do a quick refresh. And we can see here that, okay, well, I have this data right over here. I added this before, but let me add another one. Let me say clean my room. Okay, so if I save this and then I refresh it, all right, terrific. So, well, this is fine. This is what we had before. But now let me go ahead, do a kubectl get all. And I'm gonna go ahead and I'm not even gonna delete the container. I'm gonna delete the whole pod. So I'm gonna delete the whole deployment rather. So I'm gonna delete the whole deployment. So I'm gonna go ahead and do kubectl delete deployment. Delete deployment. So typically the pod is going to be deleted, not the deployment, but just to prove to you that the pod is completely gone. So we're going to delete that deployment. We're going to do a kubectl get all. So you can see here that now we are terminating this pod right over here. So this pod does not exist. It is completely gone, and basically simulating it crashing. So right now we basically don't have our data, and that makes sense. This makes sense because we still don't have our pod back up and running. So now let's just do a kubectl apply all. So let's say now that everything is back up and running, our pod is our Mongo pod is back up. So now if I do a kubectl get all, so we can go ahead and we can basically see, okay, our MongoDB pod is back up and running. Now if I do a refresh, let's do a quick refresh, there we go. So it took some time, but our data is still back, which is terrific. So that was great. The only reason why it took so long is it probably took the pod a little bit of time to get up and running again. But you can see here that our data is persisting. And actually the way that we did this here is going to be consistent with the way that we actually do it in production with an actual cloud provider. And we'll actually get to why that is through, well, that storage class that I was talking about. So I'll get to that in the next section. In this section, we're going to explore what storage classes are because they're very, very important. And the only reason why we didn't see them in the last section was because we just relied on the default version. And that's probably what you're ultimately going to be doing with almost all of your applications, just relying on the default. However, it is still good to know and understand. All right, so let's go back to this diagram over here. So remember, we have a bunch of persistent volume claims. Remember, these are just claims. They're not actual persistent volumes. And so these are basically just options. And then inside of the container, we basically are going to say that, hey, I want to use this persistent volume or this persistent volume or this one. And then Kubernetes is responsible for actually creating that persistent volume. So over here, I'm going to say, okay, well, I want to use, I want to basically use this persistent volume over here for my MongoDB container. Kubernetes, create me a persistent volume with 1 GB of storage. Well, how is Kubernetes going to do that? Well, Kubernetes needs to find a location to actually create that persistent volume. Now, for us, that location was, well, our hard drive on our local machine. Because so Kubernetes figured out that we're running this cluster on our local machine, and it's going to say, okay, well, I am going to create this persistent volume inside of our hard drive on our local machine. Because, hey, I figured it out. You also didn't specify a place for me to create this persistent volume in, so I'm just going to do it here. And that right there, the location where the persistent volume is going to be created, is the storage class. And if we go back over here and we do kubectl get, well, let's do persistent volume. So the one persistent volume that we have created, we have a storage class of host path. So this is basically, well, the host, our current computer that we're working on, we're basically using this to create our persistent volume claim. And that is pretty much that. Now, once you go to cloud providers, there's many different storage classes that we have. For instance, for Microsoft Azure, we have Azure File or Azure Disk. For AWS, we have Elastic Block Store. For Google Cloud, we have a bunch more. And so essentially what we can do is we can specify the exact one that we want, or we can just let Kubernetes figure it out. For instance, if we're running our Kubernetes cluster in AWS, then by default, it's just going to use Elastic Block Store if we haven't specified anything else. Similarly with Azure. And that's what I basically like. When we have a simplistic example like MongoDB database, we're probably just going to want Kubernetes to pick the default one. However, when we really have a fine-tuned application and we need to really pick the one that we want, then that is when we specify the storage class. So that is basically storage classes. We're not going to be using them. We're not going to be defining them right over here, but you can basically see that this is how we would define it. We would basically have some sort of YAML manifest file, and then we would just bind it to the volume. However, we're not going to be doing that. We're just going to be relying on the default. But if you want to do it, please feel free to read about storage classes in this webpage right over here. To introduce a brand new resource type known as secrets. So in this section, we're going to talk about secrets, and secrets are actually relatively easy compared to all the other resource types that we have been learning. So don't worry all too much about it. And along with secrets, we're going to learn about environment variables and how we can pass environment variables to our container. Okay, so let's say that we got an update from our developers. Our developers that were in charge of this server over here basically said, hey, we have a new version of this server up and running. So over here we have V2. And simply the only changes that were done to V2 was that they just passed the Mongo URI as an environment variable. So before it was just plain text, but now it's an environment variable. And what they want you to do is to simply just add that environment variable to that container, so to the server container. And so you could do that relatively easily. To do that, all you really have to go is to go to that container, which is going to be in the server DEPL and in the spec of the pod. And what you can basically say is, okay, well, you want me to pass environment variables, and we can basically a name of Mongo URI. So to pass environment variables in the container section, we pass the env over here, and then this will be an array entry of name and values. So we can basically say Mongo URI, so Mongo URI, and then the value of this would just be, well, the value that we had before. So this would be MongoDB : // MongoSRV, now /habits. Now, this works completely fine, and this will work. However, let's say that this right here is sensitive information that we do not want to commit to GitHub. We don't want to have it right here in our file inside of the DEPL. Now, in this case, this isn't really sensitive information because we're connecting to the MongoDB inside of our cluster, and there's really no way anybody else can do that unless they have access to our cluster itself. But let's say we were connecting to MongoDB Atlas, which is a cloud provider. Well, this would be very, very sensitive information because it would contain the username along with the password, along with other things. So we probably do not want to save this inside of our DEPL because ultimately we don't want to commit it and have anybody have access to it. So what do? Well, we do create secrets. So that's what we're ultimately going to do. We're going to create a secret that is going to house this information. And we're going to create this secret in another manifest file, but that manifest file, we're going to deliberately not connect it or not commit it to GitHub, so it's not out there for the world to see. Okay, so let's go about creating it right now. So the first thing that we're going to do is we're going to change the version to v2 because that's the version that has the environment variable. And then we're going to create a secret. Okay, so to create the secret, extremely simple. So what we're going to do is we're going to do mongo secret.yaml. And so over here, what we're going to basically have is an API version of v1. We're also going to have a kind of secret. We're also going to have a metadata, and we're going to give this secret a name. So we're going to call this Mongo, we're going to call it Mongo credentials. So Mongo credentials. And then we're going to provide it with that key value pair. Now we can have multiple key value pairs. And so over here, we would say something like string data. And the reason why it's string data is a secret has to be base64 encoded. Now we don't want to encode it ourselves. What we do is we want to provide the string and we want the Kubernetes to encode it for us. So that is exactly why we provide string data over data. Now if we wanted to encode it ourselves, then we would just say data, and then we would have the key value pair. So we're going to say Mongo URI, and then, well, whatever that value is. So I'm just going to copy it right over here. And I'm also going to just quickly double check that that is completely right. Yes, I believe so. So however, again, because we are passing in a string and we want Kubernetes to base encode it, then we just pass, well, string data. There we go. And we can pass as many things as we want in here. Of course, the keys have to be different, but we can pass whatever it is that we want. So in this case, we're just going to pass in 1. And so this is going to create our secret for us. Now, how do we use the secret right over here? So what I'm going to do is I'm going to get rid of this. And we're going to basically have to use the secret in a different way. So the name is actually going to stay the same. The name is going to be the Mongo URI, but the value is going to be different because the value, we want to get it from the secret itself. So the value, instead of using the value key, we use the value from key. And then we have to specify that, hey, we want to get the value from, well, the secret key ref. And that basically says that, hey, we want to get the value from one of the secrets that we have created. And then, well, we have to specify the secret name. And so this is the secret name right over here, the Mongo credentials. And the reason why we have to specify one of the secret names is because we can have multiple secrets. So we have to specify the secret name. And then within that secret, we have to specify the key that we want to use. Remember, we can have multiple keys. Maybe this is, I don't know, Postgres for some reason. We're storing Postgres URL in here. We're storing another secret over here. So we have to specify which one we want to use. In this case, we are going to use the Mongo URI. And so we basically specify that key. And that basically achieves the same exact thing. So now what we can do is we can commit the server DEPL to GitHub, but we don't commit the Mongo secret to GitHub. And now if somebody ends up seeing the server DEPL, well, they're not really going to get a lot of information from here. Because, okay, you have this environment variable, but we have no idea what the actual, well, URL is. All right, so let's actually do that. And okay, so that is pretty much that. And let's just make sure, again, make sure that this is version 2 for you. So what I'm going to quickly do is I'm just going to do a kubectl. I'm going to delete all my resources just to start from scratch. Okay, so we're going to delete all my resources and I'm just going to apply them again. I really didn't have to do that, but whatever, I did it anyways. So if I do a kubectl get all, you can see here that, well, now we have, we still have our pods because they're terminating. Let's just do a get all now. Now we don't have anything. Let me just do a quick clear and then do a get all. You can see that we have nothing. Okay, so let's just go ahead and apply everything. Kubectl apply -f dot. Everything has been created. Awesome. So over here we have our secret, which was created. And now if I do a kubectl get all, you can see here that, okay, our server is up and running. So what I'm going to do is I'm going to quickly log this server. So I'm going to do a kubectl logs, and I'm going to log this pod right over here. And you can see here that it's still connected to MongoDB despite us having the environment variable. And that basically means that, hey, this works nice and well. Now, one thing about secrets are not really that secure. If you have access to the Kubernetes cluster, if some malicious user has access to the Kubernetes cluster, they can figure out the secrets themselves, like what the value of the secrets themselves, and that's because they're only base 64 encoded, and they're not actually encrypted with a key. So really, they're just basically used for, well, an additional kind of layer of security. So we can basically say that, hey, now a person can't easily figure out what the Mongo URI is or what the environment variable is with secrets. But again, if the user has access to the Kubernetes cluster and has access to the secret, they can very easily actually figure it out. So that was just one thing that I quickly wanted to note. So that is pretty much this, or pretty much that. I don't know why I keep saying that. Now in the next section, and we're really reaching the end of this crash course, we're going to be talking about requests and limits. Okay, welcome back to the very last section of this crash course. If you made it this far, well, I am extremely happy. Thank you so much. In this section, we're going to be talking about requests and limits. And requests and limits are not resource types, so let's just get that clear right off the bat. I'm going to try to explain them through this example scenario right over here. So let's actually go way back when we talked about our Kubernetes cluster. A Kubernetes cluster is going to be comprised of multiple worker nodes. So over here we have multiple nodes. In this example, we have 2. And inside of the worker nodes, we're going to have our running pods. Now, one thing to note is that we have a certain amount of memory and CPU inside of this worker node. So for node 1, we have 500 memory, and then for CPU, we have 300 inside of this worker node. Now, we can never exceed that amount, because if we do, then our node inside of our Kubernetes cluster starts to fail, and that is not good. We never want that in our Kubernetes cluster. So to basically avoid this, what happens is the scheduler basically assigns the pods accordingly. So let's say we have this pod, and this pod uses 200 memory and 200 CPU, and it basically assigns it to this node right over here. So now basically the available memory that is left is going to be 500 minus 200, which is 300, and the CPU is going to be 300 minus 200, which is 100. Okay, great. So now let's say that we have another, oops, let me quickly copy and paste this. We have another pod that uses the exact same amount, and we tell our schedule that, hey, we want to deploy this. Now the problem here is that the scheduler has no way of predicting how much it is going to use. Right here we can see that it's going to use 200, but it could very well use 600. We have no idea of figuring it out. And similarly, the scheduler really has no idea. So it is likely that the scheduler can put it into this node and everything is fine and dandy, but it also could put it into this node right over here. So it could put it into here, and now we basically exceeded the amount of CPU that we have, and it could cause this to fail right over here. Now it's not really, the scheduler is not going to really try to make the node fail. What it's going to do is quickly basically evict this pod and then just schedule it to something else. But you can see here that the scheduler has really no idea, absolutely no idea as to the amount of memory and CPU that this pod is going to take. So it has no idea. So it's basically a guessing game. It's going to go throw it in this pod. If that's fine, nothing crashes, okay, that's good. But it's really a guessing game. So what we can do to make this scheduler's life a lot easier is we can basically define a request. So over here, this is another pod. And within that pod, we're defining the requests. And really, we're defining the requests inside of the container in the pod, not really the pod itself. And basically, this is saying that, hey, this is going to use around 200 memory and then 200 CPU. This is basically what we're requesting. So now what the scheduler can do is be like, oh, okay, you're requesting this. Now, okay, so it actually, so I can put it into node 1 if I'm looking at the memory, but I can't put it into node 2 because we don't have enough CPU. So basically what happens here is it's like, okay, well, I can actually go ahead and put it into node 2 because that basically passes everything. So over here, we're basically saying to our scheduler that, hey, this is possible. We're giving our scheduler a lot more information, and that way it can manage the pods inside of the nodes a lot more easily. So now we can basically decrease this to 300, and we can also decrease this to 100. However, with requests, it is not a hard limit. We could actually end up using more memory. Requests are basically kind of an estimate. We can say, hey, we expect that we're going to use 200 of memory and 200 of CPU, but we could exceed it. So we could go to like 300, for instance. So we could go to 300. And if we do go to 300, then, well, now we actually only have 2 available. So 200 available. Okay, so that is basically what requests are. Now, if we want to be more strict, and let me just copy and paste this right over here. If we want to be more strict, what we can provide are requests and limits. So basically here, what's happening is we're providing that request. So we're saying that, hey, we're going to use this, and we're also providing a limit. And a limit basically means that if this ever exceeds it, so if this ever goes to 205 or something like that, then what it's going to do is it's going to bring down this whole pod and it's going to restart it so that, you know, the memory can go back to 200. So the request is basically saying that, hey, you know, we estimate that we're going to use this, and then the limit is saying that, hey, no, this is always going to use it, and if it ever exceeds it, we're going to actually bring down this pod and restart it. So a limit is basically saying that, hey, this is pretty much guaranteed to use of maximum 200 memory and 200 CPU. And this is definitely the best thing for the scheduler, because here the scheduler can really figure out exactly what to do with this one, because now it knows 100% that it's going to be maximum 200 memory, maximum 200 CPU. Now, let's actually talk about this a little bit now. So I'm just going to quickly just copy this, and I'm going to just cut this out over here because these diagrams are a little bit better. So these are the three different basically pods and containers that we can have. We can have one where we don't define anything, and then we can have one where we have basically defined the request only, and we can define one where we have the request and the limit. Now, it just so happens that Kubernetes, what it does is, depending on what we do, it assigns that particular container or that particular pod a quality of service class. And we'll see this in a bit. Now, if we don't define anything, then this is going to be given the quality of service class of best effort. So of best effort. If we do just define the request, then it's going to give it the quality of service class of burstable. And this kind of makes sense because, you know what, hey, we're defining 200, but it could burst up to like 250. However, if we provide the request and the limit is exactly the same as the request, so over here, this actually has to be changed to 100, and the limit is exactly the same as the request, then this is going to be guaranteed. So this is going to be guaranteed. And that basically says that, hey, this guarantees that this will always be of maximum 200 memory and 100 CPU. Now, why is this important? Well, this is important because the scheduler is going to basically use these quality of assurance classes to evict these pods, and it's going to start off with evicting best effort pods first, and then burstable pods, and then guaranteed pods. So what do I mean by that? Well, if we go ahead and I basically add this node right over here, or this pod to this node, so this pod to this node, at this point now we are exceeding the limits. So the scheduler, instead of basically crashing the node, what it's going to do is it's going to evict the pods. Now, which pod is it going to evict? Well, it's going to evict this pod over here, which is the best effort pod, and it's going to leave the guaranteed pod. And it's going to try to reschedule this pod somewhere else. And similarly, if we have over here the, I know this is kind of getting big, but if we also have here the, this is the burstable pod, and you can see here that it's basically taking up too much space, it's going to evict the burstable pod and then put it over here. So if you want to basically ensure that one of the pods is not going to be evicted first or evicted last in the chain, then you want to start specifying the requests and the limits. So I hope that makes sense. Now let's actually, well, do that in our manifest files right over here. So doing this is really, really easy. It was just understanding the concepts that was a little bit more difficult. So to do this, we basically have to go to the pod where we want to specify these resources. So to do that, we would just go to, let's start off with the server. Okay, so let's start off with the server. And inside of this container, we're going to specify the resources. So we're going to do over here, resources. And basically this resource, we're going to define the requests and the limit. So over here, we have the requests. And then the request here is we're going to have a key value of memory. And here we're going to define 200 MI. And then for the CPU, we're going to define 100 M. So that is pretty much here. So here we're basically defining the requests. So we're defining the request, but we're not defining the limit. So it could actually be bursting up to 250. Possibly, but we're giving it kind of a rough estimate. So this is going to be a burstable pod. Now let's actually try to do the same thing, but now with the MongoDB container. So in here, let's specify the resources, and then we're going to define the requests. And then for the memory, let's just do 200 MI, as well as for the CPU, we're going to do 100 M. And then we're also going to define the limits here. And this is going to be exactly the same as the requests. So we have CPU 100M. All right, and then for the client pod, we're just gonna not define anything. Okay, so that is pretty much that. So now let's just do a kubectl apply -f dot. And you can see here that our MongoDepl was configured, as well as our Mongo deployment was configured, as well as our, where is the other one? Okay, along with our service deployment. So our service deployment, which is, I can't seem to find it right here. Okay, so that's a service deployment right there, and that is unchanged for some reason. I wasn't expecting that. Okay, well. Hopefully it did end up changing. If it didn't, then I'll fix it again. But the best way to actually check if it changes is let's do a kubectl get all. And then let's actually go to the pods themselves. So what I'm going to do is I'm going to basically copy this pod, and this is the client depl. This is the client depl, but really this is the client pod over here. This is just the pod name. So over here, what I'm going to do is I'm going to basically describe this pod. So I'm going to do a kubectl describe, and I'm going to describe this pod right over here. So if I enter that, and of course, I always seem to forget that it's describe, and then I have to define the resource, which is pods. So over here, I want you to notice something. Let me quickly zoom in here. Let's increase this for a bit. So I want you to notice something. So over here, if I scroll all the way down, you can see that the quality of service is best effort. So that right there is basically what I defined right over here. And that's because we didn't define anything for the client pod. Now let's actually see it for the service, or for the server. And this should be burstable. So let's do a kubectl get all. And then let's go to the pods, and we're going to get the server. We're going to do a kubectl describe pods, and we're going to describe this one. Okay, I did this a little too fast. I added an extra S. And then you can see here that this is burstable. So that is burstable. Now you can imagine that the very last one, so let's do a kubectl get all. And then we want to get the MongoDB a pod. So we'll do kubectl describe pods, and we'll describe this pod. And you can see that this is guaranteed. So that is the very last thing that I wanted to discuss, and I highly suggest that you actually do provide the requests and the limits for each pod so that the scheduler has a better idea of exactly what the memory and the CPU is going to be taken up by that pod, and so that the scheduler can basically assign it to the appropriate node. And you might be thinking, okay, how do I derive these? Well, it's really going to be dependent on your application. If your application is very big and is taking up a lot of memory and CPU, then it would have to be, well, a big number, whereas the client actually is something that doesn't take a lot of memory and CPU, so it would be quite significantly less. You can probably read a lot of documentations as to how to arrive these values, but this isn't kind of in the scope of this course. So I think that is pretty much it. So if you made it this far, thank you so much. I hope you learned a lot of Kubernetes, and I'll see you guys in the next one.